Then we see that we say 2s plus 1 is equal to 0. We say 2s is equal to 0 minus 1. Then we would have moved the positive 1 to the other side, we get negative 1. They divide both sides by 2. They will get x is equal to half or negative 0.5. Are we clear? Okay. Now let's move to the next question. Everybody clear with the first part, right?
Yes, sir.
All right. So let's move to the next part. And they say that, look at it. They say they ask me, right? What they are asking me, let me see if I can use this. If I can write on it when I'm coming. All right. So here, they want to find f g x. All right. So what I am going to do, let me just do something here quickly because I want to save the paper. Plus 1 is equal to 0. I'm doing back this one here. 2s is equal to negative 1. Then x is equal to negative 1 divided by 2. S is equal to negative 0.5. All right, so I can clear this. So I move a little faster. Okay, good. Now, anybody have any idea how to do this second one? How will I do this second question? Talk to me, guys.
So you would plug the function f into the function g, that is wherever x is, you would plug function g, I think.
Okay,
Yes,
all right. So you are
everybody
thinking,
somewhere.
all right. So you are thinking good. All right. So what we do here, you are putting the g inside the f. Everybody know, remember that you are going to put the g inside the f. So normally what I do, I tell my students, look here, let's write the g first. Let's write the last one first. The last one is g, which is equal to x minus 3, right? Then write the f last. So I repeat, you write the last one first and the first one last, right? Then you put that one to be 9 over 2x plus 1. Follow me through now. As she said, we're supposed to put all the g inside the f, right? So what we are going to do here, right? I am going to try and take all this. I'll take all this, right? And replace it wherever I have the x here, right here. So I'm going to rewrite this one for you to see. So that being, I'm going to say that f g x is equals to 9 over 2 open brackets. We see wherever I have the x, I replace it by x minus 3 plus 1. Follow? Then I'm going to get 9 over, then this time this give me 2x, right? This time it give me minus 6 plus 1. So my final answer, right? My final answer here, we are going to get now 9 divided by 2x. Now negative 6 plus 1, what do I get? Negative 6 plus 1, what do we get?
Negative 5.
Negative 5. So this is the answer we are looking for, right? So our answer, actually, right? Our answer going to be, we are going to write f g x is equal to 9 over 2x minus 5. This is my answer. So let's run through one more time. We were told to find the simplest form of expression, right? They say f g x. So this is a composite function. So normally we put the last one inside the first one. I repeat, we put the last one inside the first one. So we put the last one, which is x minus 3. We write the last one first, and we write the first one last. Wherever we have x, we replace that x with the g, whatever we have in the g, right? So here we have 9 divided by 2x plus 1. But instead of the x, I replace by x minus 3 plus 1. Then I will get 9 equals 2x minus 6 plus 1. Then my answer give me 9 over 2x minus 5. Are we clear?
Yes,
Is
sir.
anybody
Yes,
here
sir.
who lost? Casey, you get it? Casey, talk to me.
Yes, sir.
All
Sir,
right.
right,
Yeah, go ahead.
up the top there, you see, I just came on. So we have
Mhm.
x equal minus 0.5. I don't know where to work up that part there. I get this part that you're working out, but up top there, I think 8A is related to the one that you're doing now.
No, so this the first one they were asking. They said state the value of x that cannot be in the domain of f, meaning they are asking for find the value of x when the function is undefined, right? The same thing. So for that now, for you to find the value of x when it's undefined, you go to the denominator, right? You go to the denominator equal to 0, right? Then you're going to find the value of x for that function. So 2x plus 1 is equal to 0. So say 2x is equal to -1. But how do you get -1? We move this +1 over the other side. We got -1, right? Then later I want to find x. So x is going to be 1/2. 1/2 give you -0.5. That makes sense.
Yes.
You understand now?
Yeah.
Because remember that you just take the denominator now. You don't take the everything, just the denominator equal to 0, then work it out like you are working normal equation. Cool.
Yeah.
All right. So we can move on now, right?
Yes.
All right. So the next one now, they ask me to find F inverse, right? They're asking for, by the way, what is F? F is, let me write here. What is Fx? Fx is equal to 9/2x plus 1. Now, anybody remember how to find the inverse of F? Like we want to find the inverse. Anybody know the concept? What will I do to find the inverse?
I don't know. So you have to do something with the y. So you're gonna write the function, replace x with y. No, where you have f of x, you're going to put y is equal to, they're gonna write back the function, and then you're going to proceed to replacing wherever x is, you're going to put y. And then you're going to say x is equal to back to the function with y instead. Then you're going to solve it.
Thank you. So what this for there are 3 steps actually to find the inverse of a function. So step 1, you change the function to y. I repeat. So step 1, we change the function to y. So instead of fx, we say y is equal to 9/2x plus 1. Follow me, everybody. Right? So step 2, change the y to x. So this will be x is equal to 9/2y plus 1. So what we did was this: the first step is to change the function to y. Change the function to y, right? That's step 1. Step 2, change y to x. Change y to x. Then you change x to y. All right, so that is step 2. And step 3 now, we are going to make y the subject, right? So step 3 now, we are going to say x equals to 9/2y plus 1, right? Then what you do here, you put this over 1, because what we are going to do, step 3, we are going to find y. But how do we find y? We cross multiply here. That's the only way we can do. We have to cross multiply. We are going to get 2y plus 1, right? All this one here times the x is equal to 1 times 9. So obviously, the x will multiply for all this one here. So this give me 2xy. Then this time you give me x is equal to 9, right? Then what will I do next? I want to find the y here. What will I do? From this, how do I make y the subject now? Anybody want to help me? How do I make y the subject from here?
I think you find the common factor or something like that.
No, you want to make y the subject, so there's no common factor for y. You want to just make the y the subject.
So I think you're going to do cross multiply.
No, we did
Cancel.
that part already. So
Can you
we,
go
I
and
need,
do
I
it the
want
next
look at,
one?
okay, we'll move the x first, right? So you're going to move the, you say 2xy, follow me through, is equal to 9 minus x, because we want the y to stand by itself. Remember, the main thing to make y they stand by itself. The only way I can make y to stand by itself is to move the x here, which is positive, over the other side becomes negative, right? Then the next thing I have to do now, I'll get rid of the 2x, right? The 2x here is actually multiply. What's the opposite of multiply?
Divide.
Divide. So be y is equal to 9 minus x over 2x. Right. Now remember, whatever I get for y is your inverse. I repeat, whatever I get for y is your inverse. So therefore f inverse x, right, is equal to 9 minus x over 2x as the final answer. Right. So we'll run through one more time, just in case there's anybody there who struggling to understand what is about, right? So this is the answer. All right. So let's start from scratch. We were given this function, right? We are given different f. They say fs is equal to 9 over 2s plus 1. Cool. Now, so the step one, we have to change the function to y. So even though we have f, we change the f to y. Say y is equal to 9 over 2s plus 1. Then after we do that now, right, we change this y to x and the x to what? Y, right? Then the next thing I have to do, that step to change y to x and the x to y. Then this next thing, the last step, we want to find y. How do I find y here? It is a fraction, so you can, it's not that easy to find y. So the only way out is to cross multiply. When you cross multiply, you get x open bracket 2s plus 1 is equal to 1 times 9. Then you expand. You remember, when you reach, you have to expand. Why you have to expand? We want to make the y the same. We want the y to stand by itself. The only way I can make y the stand by itself, first of all, remove the bracket first. When I remove the bracket, I get 2xy plus x. Then the next thing, I get rid of the x here. The x is positive. I carry it over, it becomes negative. Then I want to get rid of what? The 2x is, sorry. The 2x is actually multiplying here, so it come in divide. We get 9 minus x divided by what? 2x. Are we clear?
Yes, sir.
Any question? So everybody feel comfortable about this question?
Yes, sir.
All right. So, oh, by the way, I will, anyway, everybody copied it already. Can I move on? I'll give you some minutes to copy. Talk to me.
Yes, sir. I'm writing it off.
Okay, good. Now, listen to me. I'll ask you, class master to write it down, right? Do not take the pictures, like screenshot them, because guess what? I've learned that when you guys screenshot them, they become archives. You don't even remember which one is which. So you have your book, you write it down so that whenever you have time, you can go through it step by step. You can get distracted with your phone. Instead of you doing that, somebody will WhatsApp you, somebody will text you, and you forget about even whatever you are going to look for. All right. Week. So let's establish that first, right? So we are going to say that the area is equal to the length times the width. Cool. Okay, good. Now, if my length is the area is equal to the length times the width, right? So normally here that have been the length, right? And this would have been the what? Width. Now, this that the area ABCD, look at it here. The area ABCD has the area of 44 centimeters square. Everybody see that? As the area of 44 centimeters square. Good. Now, that means saying when you work out this area, the answer should give me 44. But let's try something first. If I'm supposed to calculate the area of length times width, who can tell me how do I write the length and the width for this particular ABCD? That the length is made up into two parts, right? They have 3x in one part and a 4. The other side, they have what? 2 and a 3x. Anybody want to
Sir,
and work it out? Yes.
sir, would it be 3x plus 4 in brackets?
Okay.
And then
Okay, so
3x
3x plus 4.
and then
Then
3x
3x,
plus
yes.
2 in brackets as well is equal to 44.
Yes. It's equal to 44. So that is what we are going to do. Exactly. Right. So that means 3x, because why is equal to 44? It was mentioned that the area ABCD, the answer should be equal to 44. Now remember, they said that I should write an expression that the area ABCD, that my final answer should look like this. Everybody see that? My final answer should look like s squared plus 2s minus 4 is equal to 0. So let's focus first. How do I expand this panel? Now, can somebody tell me how do we expand 3s plus 4 and 3s plus 2? What do I do? How do we expand? Talk to me. How do we expand?
Sir, you're going to multiply the values in the first bracket by the values in the second bracket.
Okay, so the easy way to expand, if you don't know how to expand, right? The easy way for you to expand, it I mean you are going to take the 3x, then take the last one, 3x plus 2, yes, then be plus 4, then another 3x plus 2. Right, all this one should be equal to 44. Right, then this time used to give me 3x times 3x. What do I get? 3x times 3x, what do we get? Guys, help me out. 3x plus 3x, what do we get?
9x.
9x what?
9x squared.
All right, good. Now 3x times 2, what do I get?
6x.
6x, okay. Now 4 times 3x, what do I get?
12x.
Good. Now 4 times 2, what do I get? 8 is equal to 44. All right. Then what we are going to do now, so we're going to say 9s squared. Now 6x plus 12x, what do I get? 6x plus 12x, what do I get?
18x.
18x. All right. Then plus 8. Then we are going to, since we are going to make it this one equal to 0 now. So it'll be 88 minus 44 is equal to 0. Agree? Then this give me 9s squared plus 18x, right? Minus, now 8 minus 44, what do I get? 8 minus 44, what do we get?
Sir, 36.
36 is equal to 0. Now, so the question I'm going to ask you guys now, how will I modify this question? 9s squared plus 18s minus 36, and my answer, it should give me s squared plus 2s minus 4 is equal to 0.
Sir, you would have to find the what do you call it? Common factor.
Common factor. Okay, what number can go to all these numbers?
9.
9, right? So that means we divide each of them by what? We are going to divide everything by 9. All right. So let's try that. So I'm going to say all this one here divided by 9. Right. So this will give me 9, the left s square. 9 going to this will give me 2x. And 9 going to this minus 4 is equal to 0. And we get our answer. Everybody see that?
Yes, sir.
Then you get your 3 marks. Then you get your what? 3 marks. Any question? So remember that. So in this particular question, they test you, first of all, if you know how to find the area of a rectangle. That is the first thing they test. Then after that, they test the ability to expand and simplify, because they're not going to make it easy for you, but you have to apply your knowledge or what it requires for you to use the concepts, right, of how to find the area of a rectangle. Then you're good to go. Are we clear? Is there anybody on the platform don't get what happened a while ago? Now, so yes, go ahead. Somebody talking.
From the part where enter the 0, I don't understand that part.
Okay, Krista, speak a little bit louder so I can hear you, please.
So you hear me better now?
Yes, I'm hearing you, Krista. Yeah.
I'm saying the part where enter the 0, the 9x squared. Sorry, I don't understand that part.
Mhm. You mean how I got the 9x square?
No, sir. Where the 0 is, the expression. Yes, sir.
Okay, so I need you to read this sentence for me. Read from here. You see where I put the arrow? Read it for me, please.
Yes, sir. By writing an expression for the area of rectangle ABCD, show that x squared plus 2x minus 4 equals 0.
Right. So they said we should show that the area of this is equal to, they said that we should show that the area of this should give me x squared plus 2x minus 4 is equal to 0. So the truth for the matter is the same. We had expand this one here, they will call it to 44, right? Because they told us that you know where the 44 is coming from, right? You know where
Yes,
the 44 is
sir.
coming from,
Yes,
right?
sir.
We're giving her the information, right? We're giving that information. They say ABCD as an area of 44 centimeters square. So that's how we got that 44, right? So what we did here is this. After we get the 9x squared plus 18x plus 8 minus 44, we brought the 44 inside equal to 0. Then we got 9x squared plus 18x minus 36 is equal to 0. But they want the answer should look like this. So the only way, this is what we get. Now remember, this is what we get, right? But we want to modify this answer to get this. The only way you can get this answer is by dividing by 9, no other number. So 9 can go to 9 can go to 9, 9 can go to 18, 9 can go to 36. We get x squared, we get 2x, we get minus 4 equal to 0. Because you want the answer should look like, you want the answer should just look like the same thing they told us. You see that, Krista?
Sir, not really. I still can't get over.
Okay. No, what you don't take your time. What you don't understand? How we got the 9x?
No, sir, not the 9. Look at the expression 9x squared plus 18x plus 8 minus 44 equals 0. Sir, why the 0 is 0?
No, because they want the answer. Look at it. They want the answer this way. You see what I'm saying? What they want the answer to look like.
Let's say we have to cancel out the 44 from the side.
So right. So if you move the 44 is positive, no, Krista. So when you move it inside here, it can't. What is left here? If there's no number, what do we put?
0.
Okay, so that's how we got a 0.
Okay, sir.
You understand that now? Because you have to, if you don't move it, it will not be like that. That's the only way you can have to treat it. Everybody understand that?
Yes,
Now,
sir.
and moreover, they want the answer to look like this. You understand that? They say your answer should look, they say you should show that your answer should look like S squared. So the only way I can do this is doing it this way. There's no other way. Clear? All right. Any other question? All right. So anybody copying, or can I move on?
Sir, I want to write off the question.
Okay, go ahead. What did they say? Oh, you want to write down the question? Okay. Oh, all right. So we get 4 here, right? Then here we have -4 times -4. Negative times negative, what do I get?
Positive.
Positive.
All right, so we get positive 16. Yes, I will soon come. Hold on, 16 all over 2 times A. What is my A value?
1.
So 2 times 1. All right, so let's pause here, right? Somebody is requesting that and we go over it just for them to understand. So for those who don't know what is happening, right? We're giving S squared plus 2S minus 4 is equal to 0. Now they say calculate to 3 decimal place the value of X. Now, this question is coming from the same thing we were just doing a while ago, right? Where we got the X squared plus 2X minus 4 is equal to 0. Then later now, after that, they asked me to find the value of X and they want me to put it to 3 decimal places. Now, the trick here is this, and once they say you should put it to 3 decimal places, you should know that you cannot factorize this one in. If you cannot factorize it, it means you have to use the quadratic formula. What's the quadratic formula? Negative b plus minus square root of b squared minus 4ac over 2a. Now, you don't have to worry. This formula, will be giving this formula at the front of your paper, but you just have to know when to use it. We use this quadratic formula whenever you cannot factorize something and they ask you to solve. It's only used to solve, not to factorize. It's only used to solve an equation. So the coefficient of the S square is your A, which is 1. The coefficient of the X is 2, so call B is equal to 2, and the last one is a constant, so C is equal to -4. You substitute, forever you have B, you put 2, then plus minus square root of B, you put another 2 square minus 4, your A would be 1, your C will be -4. Then you work out -2 plus minus 2 square will give you 4. Then here you have -4 times 1 will give you -4 times another -4 will give you positive 16 all over 2 times 1, right? So we come this side now. So you get, we're going to say X is equal to -2 plus minus square root of 20 all over 2. All right, so guess what you're going to do? You're going to say X1 is equal to -2 plus what is square root of 20, please? Anybody can tell me? Somebody have a calculator to help me out, please. What's the square root of 20?
4.472.
4.472 divided by 2, right? Then we'll do another one, X2 is equal to -2 minus 4.472 divided by 2. Now, ladies and gentlemen, just remember that when you come here, right, you are finding 2 values. Using the quadratic formula, you are finding 2 values, one with positive, one with what? Negative, right? Then I need somebody to work out the first one for me. What do you get, please? Can somebody tell me the answer for X1 with the -2? So do me a favor, -2 plus 4.472 divided by, no, then divided by 2, what do we get? What do we get?
2.472.
Okay, so you get what 2 for the first one, right?
Yes, sir. 2.472.
2.472 divided by 2. So what do you get?
1.236.
1.236. All right. Now they do the bottom one. Just check the next one for me now, please. So the next one will give you a negative 6.472 divided by 2. Right. Work it out and tell me what you get, please.
Negative 6.472.
Yeah, divided by 2, please.
Negative
It's negative 3.236.
3.236.
Yes, sir.
Okay, that negative 3.236 as my answer now. So we have two values of x, right? And yeah, I just want everybody to pay attention to what I'm going to see. So we have two values of x, right? One is positive and one is negative, right? When you are dealing with the length of a line, will you use the negative one or will you use the positive one? You are dealing with a length of a line. Will you take the positive or will you take the negative? So obviously you can't say a line is a negative number, right? Because so here we are going to use this one here. Look at this. This is the answer we are going to use, right? And they said I should put it 3 decimal place, and this is already in the 3 decimal place. Everybody see that?
Yes, sir.
Any question? Any question? Any questions so far? Any question? I told you that we are dealing with the difficult things first, right? So just feel free and just roll. All right. Continue. Do I continue?
Yes, sir.
Yes, sir.
All right. So let me see. What do I do? What do I do? Okay. I need you look at the next question. What did they say? Sandrina, what are they saying?
Calculate the perimeter of the unshaded region.
Right. So we want to calculate the perimeter of the unshaded region. So let's go and look at what are they talking about, right? So you come right here and we are looking for the perimeter of the unshaded region, right? Now I need everybody to focus what I'm going to say here, right? And I'm going to use a different sketch. Then later we're just doing that. Now, so when I want to find the unshaded region, this is what I'm going to get, right? The would have been, let me use different color here, quick and fast. It would have been this side, this side, this side, this side, this side, and that side. Everybody see that? So they don't want to find a perimeter of this side. The unshaded region, meaning the place which is not shaded. That's what they want you to do, right? So the question is this here: how do we find a perimeter? That's what they ask, right? Is it the perimeter they ask?
Yes, sir.
Yes, sir.
All right. So they want me to find the perimeter of the unshaded region. I am going to do some latest sketch here so that we can analyze it on ourselves, right? So just bear with me. I need to do this sketch so that everybody will understand what I'm trying to do here. All right, good. Then we have that. All right. Now, so what I am going to do, right? What I'm going to do, yeah. Now, so work with me, everybody. We'll go through this one together, right? From B to C, everything at B to C is 3x plus 4. Everybody understand that? Because this side is 3, this side is 3x, right? And this side is 4. So when you check it out, this side is, when you check it out, this side here is going to be the same thing as the other part here. So all this part will be 3x plus 4. Everybody understand that? Do you see that?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Now, the bottom in 3x, right? Then the top, if they want to find it from A to B, the top, if here is 2 and here is 3x, that means that all these sides have been 2x plus 3x. So we're going to put here 2x plus 3. Then here we're going to be 3x. Now this side here, if from here to here is 2, that means the top also going to be 2 here. So here will be 2 here, 2 centimeters. And if all this side, if this side is 4, that means this side is going to be 4 centimeters. So they want to find the perimeter of this unshaded region. Follow me now. So how do I find a perimeter? We add up all the sides. Am I right?
Yes,
So
sir.
can somebody help me? How do I find it? So we are going to, let's start from here. 3x plus 4 plus 2x plus 3 plus 3x plus 2 plus 4. Right. So let's group all the like terms. We are going to get 3x plus 3x will give me 3x plus another 3x plus 2x, right? Plus 4 plus 3 plus 3 plus 2 plus 4. Can somebody check and see if I never leave anything out? Did I leave anything out?
No, sir.
Okay, so 3x plus
Yes,
3x, what do we get?
sir.
What I left out?
Sir, I think you left out one of the 3x's.
One of the 3x. I'm supposed to get only 2 3x.
Sir, isn't it 3?
Oh, I lie. You're right. 1, 2, 3. I left out. Yes, you're right. So which one I left out? Where did I start it? 3x plus 4. Okay. Oh, I think this one here, this one should be 3x. This one here, you see that? I never put the x on it. Thank you. So this should be 3x. 3x here. So it had been 2x plus 3. Then you have what? 3x plus the 2 plus the 4. Yes, so that would have been a missing. Everybody understand that? So therefore, I'm supposed to take one of them. Okay, let me just do this one over. So to less confusion. So it had been 3x plus another 3x plus another 3x, right? So 1, 2, 3, yes. The next one had been 2x, only 1, 2x, right? Then we have the 4 plus the 4 plus the 3 plus the 4 plus the 3 plus the 2 plus the 4. Am I right now?
So about the
Am I-
2x at the top,
Come again.
the 2x plus 3x.
Sir, it should be
2x.
3x plus 2, I think.
the top would have been 2x plus 3x. That's fine. That's okay. Now remember no, that this side was 3x, no, so and this side was 2x, so it'll be 2x plus 3, then 4 plus x, the other being 3x, the other being 2, and the other being 4. Yes, so everything should be okay.
Sir,
So
the top-
let's go.
Sir, the top
Huh?
should be 3x plus 2. Only not
3x,
plus 2.
or the top 3x. Oh, 3x plus 2. Let me see. Okay, yeah, I've seen it. Right, 3x plus 2. Oops. All right. Okay, this x thing. So let's go one more time. Okay, so the top would have been 3x plus 2, right? I think I made a mistake from this side here, that's why. So here should have been 3x plus 2, 3x plus 2. All right, cool. So let's go. I'm starting from here. So it'll be 3x, right? Plus 3x plus 4 plus 3x plus 2 plus 3x, right? Plus the 2 plus the 4. We're good now? We good now?
Yes, sir.
Yes, sir.
No. All right. So it had been 3x plus 3x, right? Plus another 3x. So 1, 2, 3, 4. Okay. Plus another 3x. All right. Plus the 4, plus the 2, plus the 2, plus the 4. All right. So 3x will give me 6, 9, 12. So get 12x here, right? Then all this will give me 6 plus 12. All right, good. Now remember, what's the value of x? What do we get for the value of x?
One point.
1.236.
So it will be 12 times 1.326, right? Plus 12. Now remember, we are finding the perimeter. So what I will do, wherever I have x, I replace the x by what? I replace the x by 1.326.
Sir, it's 236.
236. All right. 236. All right. Okay, let me just. Come again, 236. Am I correct?
Yes, sir.
Okay, all right. Now do me a favor, multiply that for me and see what we get. So multiply that and tell me what we'll get.
14.832.
No, take your time with me. 14.832 plus 12, right? So let's add plus 12 and see what we get now.
38.832.
38. All right. So I just come in. I'm just going that side so everybody to see. Okay. So when you come here in your exercise paper, right? In the exercise paper, this question, this is what you are going to write, right? You come all this one here and just write it in the space. Everybody understand what is happening here? We are going to write in the space here. What do you have now? What do you say you got?
38.832.
38.832, right? Centimeter, right? Yeah, centimeter. Because they want to answer to 3, there's no, they never say about answer for that. Are we clear?
Yes,
So you
sir.
can go ahead, those who are writing, you can go ahead and just do that for me quick and fast, right? Whilst I try and write it over with. So let's go again. So we are saying that the PQ and the SP, they are parallel. And this SQ is acting as a traversal line. So this angle here, this angle and this angle form a Z angle. Everybody can see the Z angle on it. So if it's a Z angle, that if it's 30, there is going to be 30 degrees. Now, the other thing we can also do, who can tell me what will be the angle right here? All this one, all this angle, what will it be? If this one here is a trapezium, what would be all the angle here? What will it be? If they ask you what is the angle PSR, right? You want to find all this angle, what will it be? Easy one, too. Nobody?
Sir, is it 90?
Yes, it is 90. Yes, that should be 90 degrees, right? So this will be 90 degrees. So so the point I'm trying to make here is this, somebody can use the alternate angles to get this side to be 30 degrees, right? Because this angle and this angle form their angle. But at the same time, too, somebody also can use this one here, say that all this side should be 90. So if there is 30 degrees, that means here is going to be what? 60. Everyone understand that? So two ways. So, and also remember that the sum of the interior angle of any triangle have to add up to 180. So this is 60, this is 30, and this is what? 90. Follow me through. So basically, what are we saying here? Is that there will be 30 and you're going to be what? 60, and here it's 90. So when you add up everything, you get that 180. So somebody can use this one as the point angle of reference. Somebody can use the 60 as the angle of reference. But at the end of the day, we get the same answer. So the question is this: which of the angles you are going to work with? Are you going to work with the 30 or you are going to work with the 60?
30.
30, okay. So if you are working with the 30, if you're going to work with the 30, so we draw the line right here. This is the angle of reference. They'll label the side. These are going to be opposites. All right. So we use there will be 30 degrees. Here will be 60 degrees. We are using this as angle of reference. So if you are using this side as angle of reference, that means what do I call this side? If the line, what do we call this? There will be opposite, right? Opposite. What do we call this one?
Hypotenuse.
What do we call this one?
Adjacent.
All right. So if you are using the 30 degrees as the point of reference, I repeat, we are using the 30 degrees as the point of reference. We are giving the hypotenuse and want to find the what? Opposite. Which formula comes to our mind? So, all right. So it's so comes to our mind, which is sine. So here we are going to say that sine of 30 degrees is equal to opposite over hypotenuse, right? So sine 30 degrees, my opposite would have been PS over hypotenuse, which is 8. Then we put this one over 1, then we cross multiply. We are going to get sine 30 degrees times 8 is equal to PS. Now, can somebody tell me what is sine 30 degrees, please?
0.5.
So 0.5 times 8, right? So 0.5 times 8, what do I get?
4.
4, so get 4 what? Centimeter. Everybody agree?
Yes, sir.
So PS is equal to 4 centimeter. We get our marks. So the most important thing here, guys, is to find the angle of reference, right? Whether you use the alternate angles, the Z angles, or use angle PSR, saying that it's 90 degrees, the one part is 30 degrees, the other part would have been 60, right? So you can also make a point, right? That all these angles should be 90 degrees. All right. So if one part is 30, the other part would have been what? 60. You can also use that. And so that if you're 60, you would have been 32. So that's another thing. All right. Now, what is the next question? Any question regarding to this question? Any question? All right. So let's see. Okay, let me clear this one first. The access to find the length of PQ now, right? Now, the access to find PQ, the length of PQ. How will I find the length of PQ? So let's try and sketch. I'm going to try and sketch. I'm going to try and sketch it, right? So here it's like this. Am I right? Let me see something. Oops. Okay, we have something like this, right? What letter was here? This is P and this is Q. Am I right?
Yes, sir.
And this is your S. All right. Then we just found this one. This one was 4 centimeters, right? This one was 8. Am I right?
Yes, sir.
Right. Now, then they want to find PQ. Yeah, this side 4 centimeters, this side 8. And this side is a right angle. What will I do? I want to find PQ. Which formula? You are given 2 sides. You want to find the third side. Which formula comes to your mind?
So when the C square equal A square plus C square.
Right, C squared. What we call it the Pythagoras theorem, right?
Yes.
So that means C squared is equal to what? A squared plus B squared, right? So which side is my C, by the way?
Hypotenuse.
The hypotenuse is my C. The other one can be A or what? B. Good. All right. So C squared should have been SQ squared. So it would have been 8. Instead of that, I'm going to put 8, right? So I'll put 8 squared equals to A. My A is 4 squared, then plus PQ squared. Right. So it'll be 8 squared. 64 is equal to 16 plus PQ square. What will I do next?
We're going to show what is the positive 16.
Because positive 16 will be 64 minus 16 is equal to PQ. Yes. What will I do next?
Then 48.
So get 48 is equal to
equal
PQ.
to
Yes. So
And
square root of
expand the
48.
square root
Yes. Of PQ. Yes.
6.928.
6.928. All right. So if you want to put two decimal places, right? You want to put the answer in 2 decimal places, you get what? 6.913. All right. We could so far. Is anybody lost? So PQ is what? 6.932, right?
Oh, sir, one question.
Sure, go ahead. Go ahead, Sadrina.
Sir, I was wondering why I never use the trig ratio for the length PQ.
No, you have the choice. So you could also use trig ratio. Now, the fact that I used trig ratio before, I just, because we are learning, I have to use the Pythagoras theorem. So at least everybody will balance it out.
Okay. Sir.
But there's nothing wrong, Sadrina. You could have used, let me tell you, you could have used cos 60 degrees, right? Cos 60 degrees to find PQ, or you can use sine 30 degrees to find PQ. No, PQ, sine, no. It would have been,
Yes, sir.
if it's 30, that would be adjacent, yeah, because, right? Then the other one will be, no. So you can use tan 60. You can use tan 60 to find the PQ, or you can use cos 30 to find the same PQ.
Okay, sir.
Mhm. Look at the last question here. What them say? They asked me to find the area. Right. So I just want us to look at this question here. Ladies and gentlemen, how will I find the area of this? This is what they want you to find the area of this shape here, PQRS. Now, I need you to tell me, find the area of this. Figure it out. How will you find the area of PQRS? PQRS, how will you find the area?
Sir, isn't there like a trapezium rule or something like that?
Oh, it's a trapezium, right? Good. So it would be a trapezium. But how do I find the area of a trapezium? How will you find it? What's the formula to find the area of a trapezium? Everybody know? What's the formula to find the half? Yes. So it's half
Open bracket.
Mm-hmm. Yes. A plus
B.
times the height. All right. So it'd be half A plus B times that. But that's the area of the trapezium. So this side is your length. Normally here would have been A, right? This would be A, and this would have been B. We know the A, we know this would have been the H, right? We know the A, we know the no, so we know the B, we know the H, but we don't know the A. We don't know what is this side, the SR. So for me to find the area indirectly, I need to find SR before I can go ahead and find what? The area of the trapezium. Do you understand what I'm trying to say here? Let me go one more time. For me to find the area of this trapezium, I need to find the length of SR before I can proceed, do anything. So the question I asked, is anybody here can help me how to find SR? Right, how will I find SR? Once I'm able to find SR, then I am good to go. So how do I find S to R? How do I find S to R? Anyone? Any idea? Now, let me ask a question. SQR, what type of triangle is it? No, wrong question. SQR, is it a non-right angle triangle or a right angle triangle?
Non-right angle triangle.
Come again.
Sir, non-right angle triangle.
It's a non-right angle triangle. Good. If it's a non-right angle triangle, then it means I can use trigonometric ratio. I can use Pythagoras theorem. So what's the next option do I have to find that? So we can use trig ratio because it's a non-right angle triangle. We can use Pythagoras theorem because it's a non-right angle triangle. So we have to find an option. How will I get that?
So the cross formula.
The cross formula. So no, explain yourself. What do you mean by cross formula? I understand. I pick up what you are trying to say. I say the cross formula.
There's the sine rule.
The sine rule, right? So she said the cross formula, but I know that she's talking about about the cosine, no, the sine words rule. But I have issue here. So for me to use the sine rule, I need to figure out this side is 8, right? This side is 30. Where will I get my matching pair? For me to use the sine rule, I need a matching pair, meaning I need to find the angle on each side. But here, I've only angle, but this side no side. Can I find this angle? Is it possible for me to find this angle? Is it possible for me to find this angle? Look at it carefully. Can I find angle R? Is it possible for me to find angle R? Sadrina, what do you say?
Sir,
Casey,
angle R.
how will I find angle R?
Sir, I think you go plus the 30 and the 82 and then you minus it by 180.
Yeah, you're right. So you add the what? You add it because if you don't do that, you can never find SR, right? So the first thing we have to do, right? The first thing we have to do, I think what I'm going to do, I'll try and sketch it on the other side, right? So that we can see through that. Just give me a minute, guys. So P SRQ, right? SRQ. So let's go back. We have to sketch it so that everybody can see that. Is that okay? So where was that? Okay, so I'm just going to do some little sketch here so that before I do anything, before I even go back and find the area, right? I am going to give me a minute, guy. I'm going to try and write it here, right? So before I do anything, I am going to find, I'll draw that part first. I'm going to draw that part before I draw the trapezium, right? QRS, right? QRS, okay, QRS. This is Q, this is R, and this is S, right? What was this angle here?
82 degrees.
82, so there be 82, right? And this angle was what?
30 degrees.
30 degrees, all right? Okay, so we are going to find, first of all, we're going to find angle SRQ, right? Which will be equals to 180 degrees minus 82 plus 30 degrees, right? So you get 180 degrees minus, when you add this to what we get, 112. Is it 112?
Yes, sir.
All right, so minus that now, what do we get?
68.
We get 68, right? So we get 68 here. So that means this angle here would have been what? 60 what? 60. Now remember that we want to find SR. So first of all, once we do that now, we know that what was this one here? This was 8, right? SQ was 8. Am I right?
Yes, sir.
So put 8 centimeter. All right. So let me hold on, guys. Let me see. Say, can you bring back the question to PQ? All right. Quickly, somebody's asking, can you bring back the second? Okay. So just give me a minute. Somebody asking me to go back to PQ. We soon come back to that quickly. Yeah, this is PQ. Okay, good. All right. Nas, can I move on now? Okay, good. Thank you. All right. So we come here, right? All right. Then we see what 82, 30, 68, right? We work it out, we get that. Now the next thing I'm going to do, I want to find SR, right? So for me to find SR now, I'm going to use the cosine rule. Somebody say that the cross something. Yes, you use the cross same something. Me not wrong you. So cross something. Since we want to find this, we match this one with that, and this one. That is the matching pair. This is our matching pair, right? The matching pair is the 68 and the 8, because we don't have to come up with that. And we want to find SR. So we name it small q, this one small r, and small s. And so we are going to use the sign rule now, right? So for the sign rule, anybody remember what will I write the sign rule formula?
Sir, A square equal.
No, a square equals to, that would have been the cosine rule. You don't want this, that you want the sine rule. Do you remember the sine rule? Okay, which two angles am I going to do? Right. So it normally is A over sine A, B over sine B, and what? C over sine C. But here we are using two different letters. We are using angle R and Q, right? So I'm going to say R over sine R is equal to Q over sine Q. My small r will be 8 centimeter over sine 68 is equal to Q will be SR, which I'm looking for, over sine 82. So I repeat, when do we use the sine rule? We use the sine rule one if what we are given is a non-right angle triangle, right? If what we are given is a non-right angle triangle, and two, we have what we call the matching pair, right? Matching pair meaning they give you the angle on the side. So by in this particular scenario, they would never give me angle R, but I still could find angle R because this side was 30, this one's 82. I minus and I got 68, so I can get the matching pair from that. Right. So once I get my matching pair, meaning I know the angle and I know the side. Once I know the matching pair, then I can match the side I'm looking for with its angle. Right. So you just say R, they label the side R, S, and Q. You say R over sine R, Q over sine Q. Your small r will be 8 over sine 68. Then small q will be SR over 82. Right. Then I'm going to work out this one. We cross what? I'm going to cross multiply here, right? I cross multiply. So when I cross multiply, my next stage is to say 8 centimeter times sine 82 is equal to SR times sine 68, right? So 8 centimeter times sine 82, right? Okay, sorry. What is sine 82 for the meantime? What's sine 82, please? Anybody can help me? 3 decimal places. Sine 82. Can you speak a little bit louder, please?
0.990.
990. Thank you. Is equal to SR time. What is sine 68?
0.927.
All right. So what we are going to do, let's multiply these two now. 8 centimeters times 0.99. What do we get?
0.92.
Come again.
7.92.
All right, it's got to SR times 0.927. And I want to find SR, right? Then I'll say 7.92 divided by 0.927 is equal to SR, right? So let's find what is SR now. So go ahead and work it out. What is my SR?
8.54.
54. All right, 8.54. All right. So we are now going. So after we finish all this, right? We're going into the trapezium business now. So this is how we have in here now. I'm going to sketch it down. Right. This is the trapezium. Right. So this one was the right. So this is Q. This is S. This one is the S. This is the R. Right. This is P. Am I right? P. All right. This side here was 8. This side was 4. What do we get at the PQ? What do you get for PQ?
6.93.
4.93 or 6? No, it's 6,
Four.
right?
6.93.
6.93. Now, and we work out this one a while ago. What do we get for SR? SR, what do we
8.54.
8.54. Now, so now, so you see, look at it. You see CXC easy. They ask the students to find the area of PQRS. Now, the students, first of all, for them to answer that question, they have to find what is angle R. After they find what is angle R now, they have to go and use the sine rule to find what is SR before they can even think of working the words, the area of the trapezium, right? So I know that sometimes the questions are kind of weird, but you just have to have an open mind, right? That you're going in to use your knowledge to do most of the work. So area of the trapezium is going to be half bracket A plus B times the height. So we come and say half. Our A would be, I name here A and name this side B, right? So A would be 8.54 plus 6.93. It's kind of old. I need to get a space. Let me just go in it over and write this. Okay, so let me, so A this will be equals to, I'm starting in half brackets 8.54 plus 6.93 times 4. Right, times 4, right? We multiply by 4. So this will give me half. Can somebody add this one for me, no? Can somebody add 8.54 plus 6.93 for me, please?
15.47.
15.47, right, times 4. All right, so 2 goes to 1 time, 2 goes to 2. So multiply 2 times 15.47 and tell me what you get.
61.88.
88, right, centimeter what?
Yeah.
Square. So this is, before you see, we have to go through all this process before you can get our what? Answer 61.88 centimeter square.
Sir, what time
Yes.
for what? 15.47 times 2.
Yeah. Hold on. No, so yes, we're supposed to multiply it by 2. So the answer is wrong there. I think what they should have done is this, because we cancel this one here. So this one here divided by 2, what do we get?
30.94.
Right, so let's divide this one by no, because we remember what we did. 2 going to 4 give me 2 times, then 2 times this will give me 30 point something. So I have to go back and rectify that answer. All right, so we would have considered that already. All right, so let's go back. Yep.
Sir,
Yes, go ahead.
you can scroll up to the question before this one.
Sure, I'm coming. Then let me just finish with this session part. So 2 times this, what do we get? 30.1?
94.
No, 30.94. Okay, so 30.94 centimeter square, right? So we do all this just to get answer. Okay, somebody asked me to go back the one. You mean this one here, PQ, or the original question?
So the
You want to
subject as I scroll level.
okay, this one here. All right, this one here.
Yes, sir.
All right.
Okay, sir.
Okay. All right. So remember, guys, you have to have an open mind, right? The questions are not coming easy at all, right? You just have to apply and apply. So you have to know your stuff. If you don't know your stuff, you're left behind. All right. Okay, so we have that. All right. Everybody clear?
Yes, sir.
All right. So let's go now. We are going to do matrices.
Down to the trapezium formula right there. Finish right there, please.
Sure, no problem.
You can skip now, sir.
Okay, good. All right, so we'll reach matrices now. So they say you should find a matrix product. So you're supposed to multiply this one for me, right? So take your time and right. So remember that we multiply the row by column, -1 times k plus 3 times 5. Then later multiply the 4 times k, then h times 5. So when we multiply this one here, negative, so this one here, what do we get? Negative k plus 15. The other one will be what? 4k plus 5h. Right? This is the answer. You don't go any further. We're good so far. Is anybody here who don't understand what What is being done a while ago? Anyone? Okay. Can we look at the next question? Can we look at the next question?
Yes, sir.
Yes, sir.
Guys, don't sleep on me, no. It's too early to sleep. I need you alive. And you guys need to keep me alive. All right. So they say ends. When they use ends, what comes to your mind? When they use the word ends, what are they referring me to? Meaning
last question.
otherwise.
The previous.
Right. The previous, so you're going right. So you're using the previous one. You're using the previous question to answer the question. Now we're going to use the previous question now to answer the word question. So we are going to write negative k, right, plus 15. Because when you multiply these two, that's what you get. The other one is going to be 4k plus 5h, right? This should be equal to 0. So this answer is here, right? This answer, when you multiply, it should be equal to what? 0, 0. Now they asked me to find the value of h and k. What do you think I would do to find the value of k here? And how will I find the value of h? What will I do?
So you're going to make K the subject.
You are going to make k the subject from the first equation, right? So you're going to write negative k plus 15 is equal to 0. All right. So what will I do next?
So it'll be negative K equal 0
Mhm. Mhm.
minus 15.
Yes. Then what next?
So it'll be negative K equal negative 15.
Right. So you say k is equal to negative 15 over negative 1, right?
Yes, sir.
So negative cancel. So we get what? K is equal to 15. Everybody agree? Then the next part now we are going to say 4k plus 5h is equal to 0, right? What will I do next?
You're going to place anywhere you see K, you're going to put 15.
Right. So everywhere we find, so it'll be 4 times 15, yes, is plus 5h is equal to 0. Yes. What next?
Yeah, we'll work out what is in the bracket first.
Which will be what? So that will be what? 4 times 15, what do I get? We get 60. All right, plus 5h is equal to 0, right? And when you find h, what will I do?
So I'll say 5h equals 0 minus 60.
All right, then what next?
5h equal negative 60.
And I want to find h. How do I get h now?
I can
Negative 60 over
Divided
5.
negative 60 by 5.
Right, then what next now?
You're going to get your answer.
Which will be what?
Negative 12.
Negative 12.
Okay, so we get negative 12. Everybody get that now? So we get negative what? 12. Cool, everyone. So sometimes you just have to be a little bit more aggressive, right? and go about whatever you're looking for. Cool.
Hello, sir. You can scroll back up. Let me write off the first one.
Which one?
The one up top, the A section A.
Or the mean for that one? This one? But you understand it though?
Oh yes. Oh yes.
Okay. All right. So Ogno, we finish. You finish, right?
Yeah, I'm finished.
What I did, I tried to get rid of either the X or the Y. And I got,
Oh, hold on, Ali. So you use method of elimination, but
yes,
yet look at what they say. They say you should use the what? They say you should use the matrix what?
So I don't even
Method.
know which method that is. I just do it how I know I should do it, but it's probably wrong.
Okay,
So that.
All right. So even though you got the answer, listen, even though the answer, but you know that CX would have marked you down because they asked you to use the matrix method. You understand what I'm saying?
Yes,
If they say you should solve the simultaneous equation, that's fine. You'd have gone down and do that. Perfect. But in this case here, the question is asking you to use the matrix method, right? But if you know how to do matrices, it should be okay. But let's see how to do that. Devon, you want to help me do that?
Repeat, sir.
Do you want to help me to do this, please? What's the first thing that I've established?
So you'd have to put it in the matrix format.
Right. So the first thing, so rule number one, you put the simultaneous equation in matrix form. How do we put it in a matrix form, please?
You put all the coefficients for
The coefficients. So it'll be 2, yes, then what?
3,
Yes, then what?
-5 and 1.
-5 and 1. Right. Right. Then what do I
And
put here
then
now?
X and Y
X and Y, yes. They put the one.
is equal to the 5 and 13.
5 and 13. So ladies and gentlemen, this is the matrix form. So even though you were not asked to write in the matrix form, you have to know that before you can work out this, right, you need to write in the matrix form, right? So 2, 3, -5, 1, X, Y, that. All right. So normally, so if you don't know, we call the first matrix A, right? So when I'm doing this one will be your A, this is your A, this will be your X, and this will be your B. They have the formula X is equal to A inverse times B. So this is the formula we are going to use to solve the simultaneous equation. X is equal to A inverse times B, right? So the main focus right now is to find the inverse. Now, when we get the inverse now, then we multiply the answer for the inverse with the B and we get our solution. Cool. So what do we do?
Sir, first you need to find the
So hold on for me. So let's
determinant and
okay, we find the determinant. So the first thing we're going to find the determinant. So what's the formula for the inverse? Let's try and write it down first. You remember the formula for the inverse? 1 over determinant of A times the adjoint of A. Do you remember it now? Right. So first of all, it's 1 over determinant of A times the adjoint of A, right? So this will give me 1 over. How do you find the determinant? Anybody remember how to find the determinant of A?
sir, it's the Product of the leading diagonal
Right.
minus the product of the non-leading diagonal.
Okay. So in layman term, what are you, because some people even don't know exactly what you are talking about, the leading and the non-leading, right? So how do I explain it to them? So what she is saying, you see this one here, you see here, we call it leading diagonal. We call this one leading diagonal, and this one here going this way like this. We call this one non-leading, or we call it, or just other diagonal, right? We call it other diagonal. It's easier. So this is leading and this is the other diagonal, right? Other diagonal. So is the product of the leading diagonal, which would have been 2 times 1, 2 times 1 minus the other diagonal, product of the other one, -5 times 3 times the adjoint. Anybody remember how to find the adjoint?
The adjoint is, you switch the position of the values in the leading diagonal and
Okay, so let's do that. Let's do that first. So you're going to switch the positions of the leading diagonal, right? So you put here 1 and we put here 2. So you look at it. It was 2 and 1, but we switch it to 1 and 2. Right. So we do that. That's how you find it. Then what's the next one now?
you multiply the values in the other diagonal by -1.
Okay, so in other words, you change the signs. Just the simple layman term. You change the signs to the other words, diagonal, right? So this is -5. It turns to +5. And this was +3. It turns to -3. And that's how you find the adjoint. Everybody understand that? So let's go again. How do we find the adjoint again? We switch the leading diagonal, right? Switch the leading diagonal, the 2 and the 1, switch it to 1 and 2. Then for the other diagonal now, you change the sign. So wherever you have -5, you change it to +5. And when you have a +3, you change it to what? -3. Right? Remember that you don't switch it, you only change the sign of the other diagonal. Now then we go ahead now. So this will give me 1/2 minus 15. Right. Then what? 1 -3, 5 and 2. So negative give me positive. So you get 1/17 bracket 1 -3, 5 and 2. So ladies and gentlemen, if we have been asked to find, supposing they only gave me this matrix here, 2, 3, 5, -1. And they said I should find an inverse. This is how I will find an inverse. The inverse is 1 over the determinant times the adjoint. So the question is, how do you find the determinant? You is the product of the leading diagonal minus the product of the other diagonal. So you multiply the 2 times the 1 minus the product of 5 times the 3. Then you get 2 minus 15. Then you're going to get 1/17. So 1/17 times the adjoints. But how do you find the adjoints now? You switch the leading diagonal, right? We switch the leading diagonal. 2 and 1, we switch it to 1 and 2. Then we change the other diagonal, -5 to positive and +3 to what? Negative. Cool. Then we basically have the answer right there. But we're not yet finished. They asked me, so now when I finish everything now, I am going to multiply, right? So we say X is equal to A inverse times B. So wherever I have X, I put XY. Then my A inverse would have been 1/17 times 1 -3, 5 and 2. You're going to multiply the B by, what is our B now? So go back and look at what was the B. The B was 5 and what? 5 and 13. So this give me 1/17. You multiply row by column, right? So it'll be 1 times 5 right? 1 plus -3 times 39. No, -3 times 13. Then the other one will be 5 times 5 plus 2 times 13. So let's change this one to 13 here. Right, so this means 1/17, right? 5 plus -39. Then that will be 25 plus 26. Now, what do I get in the bracket? What will I get now? 1/17, right? So this give me, what do I get here now? -34, 51, right? So this give me -34 times 1/17, right? For the X, and the Y will be equals to, the Y would have been equals to 51 times 1/17. Now, when we work out both incidents, right? So here we would have used 70 goes 70, give me 1 time. 70 goes into this, give me 2 times. So the top answer would have been -2. Then 17 goes to 1 time, 7 goes to 3 times. So that will give me -3. So it's therefore X is equal to -2 and Y is equal to +3. So the Y should be +3, not -3. All right, so look into it again. Guys, do we follow through?
Yes, sir.
Remember, it's too early to sleep. All right. So if you're copying, do copy everything for me. Should I go a little bit up, a little bit more? So let's go through this one, right? So the first one here, they say that the angle at the center is twice the angle at the circumference, meaning if I am given, right, meaning this is the angle at the center, right? This side is the angle at the center, and this is the angle at the circumference. That is when it touches the circle, right? That's the circumference. Now, so what they are saying here is this, right? If this angle here, if this side is 50 degrees, right, what will be the angle here? If angle A is 50, what will be the angle at the center? Who can tell me?
100.
100. All right, good. Now, so they say the angle at the center is twice the angle at the circumference. Are we clear with that? That is straightforward. So you have to try and memorize them. That's the only thing, you know, you try and memorize them and how to apply them. You memorize and how to apply. Next one, angles in the same segment are equal. So look at it. These two angles are the circumference, right? They're in the segment from this side. Look, from here to here, they are showing the same arc segment. So once they are showing the same arc segment and they are on the circumference, they are the same, that they are equal. So that means if this side is 30 degrees, this side is also going to be 30 degrees. If I should draw another triangle like this, going this way, they are also going to be the same 30 degrees. Why? Because it's coming from the same arc segment. Are we clear on that? We good so far? So that should have been the first one and the second one. The first one is angle at the center is twice the angle at the circumference. The next one is the angle in the angles in the same segment are equal, meaning angles showing the same arc segment, they are equal. All right. Then the third one, they say that the angle in a semicircle is 90 degrees, right? So this is the semicircle, right? Then, so remember that this side is 180 degrees. Half of 180 will give me 90. So this one in the first one is almost the same thing because this is angle at the center, right? 180, half of 180 will give me 90. So we see that the angle in a semicircle is 90 degrees. The angle in a semicircle is 90 degrees. That's how we got this one here. Follow? So do you understand the first three so far?
Yes, sir.
They'll move on to this one now. The fourth one, they say opposite angles in a cyclic quadrilateral add up to 180, right? Opposite angles in a cyclic quadrilateral add up to 180. So A plus B will give you 180, and the C plus D also give you 180. I repeat, the A plus the B will give me 180, and the C plus the D also give me what? 180. So that means if this side is 60 degrees, what will be the angle B? If A is 60, what will be this one here? If A is B, what will be angle B? What is going to be angle B? Somebody should talk to me now.
60.
No, it can't be 60. Opposite angle, James, opposite angles in a cyclic quadrilateral add up to 180. So A plus B should give me 180. So if here is 60, what will be angle B?
120.
120, right. Now, so the C and the D also should add up to 180. So if this side is 30 degrees, that means this side should be what? If C is 30 degrees, D should be what?
150.
150, yes, 150, all right? Because here now, they say opposite angles in a cyclic quadrilateral add up to 180. What are cyclic quadrilateral? Cyclic quadrilateral are four-sided figure which touch each part of the circle. Cool? Now they say that the next one, the perpendicular line formed from the center of the chord bisect. So that means if this is the chord, then the radius from here, they say the radius will divide the chord into two equal parts. That is straightforward. So you have the radius, right, and you have the radius, so you have a chord. When you draw the chord, the radius would have, from the center going down, perpendicular to that would have divided the chord into two equal parts. Then we have this one here. The angle between the tangent and the radius is 90 degrees, right? So this one is called the radius, and this line we call it the tangent line. This one we call it the tangent, right? So they say the radius and the tangent forms 90 degrees. So once they meet at a point, they form a 90 degrees. So this is 90, and here also going to be 90. You follow?
Yes, sir.
Now, then here now you have tangents from a point outside the circle is equal to the length, equal length. So you draw one tangent line and you draw another tangent line. When you meet at a point, they are equal in length, right? So that has been straightforward. When you draw two tangent lines from a circle, they meet at a point, and if here is X and here is Y, and you put here A, if here is 8 centimeter, here is going to be 8 centimeter. Why? Because the length from X to A is the same thing going to be from Y to A. So the next one, we are going to look at what we call the alternate segment, which is very important, right? So for the alternate segment, this is the tangent line, right? Then the angle between the chord and the tangent line here, right? This angle and this angle here, they are the same. So you do this one, like you look at it like you are here and you're looking at this angle, right? And later you are the B and you're looking at the what? The other what? Angle. Right. So you have to be careful with that one. It look like a Z angle, but actually not that, right? But in a way, right, you have to find something to identify what you are doing. So the A will go across going up, and the B will come from here going where? The same direction. So we call it the alternate segment theorem. Yes, Tanoya?
Excuse me, sir. For the
Yes.
second theorem, is it the same as saying angles standing on the same chord are equal?
Yes, you can say that. Yes. That's fine. So the idea, Tanoya, you find every ways and means for you to understand what you are doing. That's fine, because you are right. Because if I should draw a line like this, right? The all of them are standing on the same chord. You understand that? And they'll be equal. That's fine. Any other question? Now, so listen to me. You need the most important one is this 1, 2, 3, 4, 5, and 6. Now, you need to know this 6 here on your fingertips. If you want to answer any security theorem question, these are the 5 you have to pay attention to. The other one, you can always go around them. The first one, the second one, the third one, the fourth one, the fifth, and the sixth. And remember that in CXC, you can't say theorem 1. We don't know what is theorem 1. We don't know what is. You explain which theorem you are dealing with. Right? So you see how it looks simple here, but you have to go and apply your knowledge when you are being asked to do the work. Any question? Any question? Pay attention to the last one we did, right? The alternate segment theorem, right? It's kind of different and kind of tricky. So you pay attention to that one. Are we clear?
Yes, sir.
Okay. Now, this is what I'm going to try to do, guys. I'm going to try and see if I can get this one and match it up with the past question we were about to look at. Then we'll see the ways and means that can help us towards do the work. All right, so let's try that. So I have to clear all this. Can I clear the screen? Can I clear the
Yes, sir.
screen?
Yes.
Now, so if you don't know them, what you do, you can just screenshot this one. This is a good thing to just screenshot it and put it somewhere, right? And use it as a guide when you are doing your work. That's all you need to do. All right, so let me just do something here now. I am going back to the paper I was doing. Okay, just give me a minute, guys. I need to do something quick and fast. So I have to go and take the questions and manipulate it. Let's press enter. I'm doing my latest stealing here and there, so forgive me, guys. So we are saying that in this angle here should be angle B, angle ABC should be 90 degrees by, because it's opposite to the diameter, and angle in a semicircle from 90 degrees. So all what you have to do here, for me to get the answer for this, right? for me to get answer for this, I am going to say that this should be 90 degrees minus what? 46 degrees, right? Which will give me what? 90 minus 46, what do I get?
44.
44 what? Degrees, all right. So the first answer will be 44 degrees, right? Now, if you want to put a reason, I'm going to say that angle in a semicircle, forms 90 degrees, forms what? 90 degrees, all right? And as simple as that, angle in a semicircle form what? 90 degrees, because this is the angle opposite the diameter is from 90. So if this side is 46, 46 minus 90 will give me 44. Cool. Okay. Let's look at the next question. What is the next question? DC what? A. DCA, 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 DCA. They want to find this angle, right? Everybody see that? DCA. They want to find this angle here. How will I find this angle here? Now, open your eyes and look at something carefully. How will you find DCA? DCA. He said, I found something while ago now. Oh. I found it. DCA. Anybody find DCA? Anybody? You don't see anything? I need you to observe something here. Right. This is the angle we are looking for, right? Is there any angle which is similar to this same angle here? Maybe they are sharing the same arc segment. Tanoya, the question you asked me earlier on, do you see anything which can be based on that?
Sir, I'm not sure. Is it angle standing on the same chord?
Right. So right? So there's angle on the same chord, but look at it carefully and tell me which two angles are on the same chord here. Okay, somebody send me something. Angles on the same chord. Let me see if the person sees it. Casey, no, Casey. No, it's not that. Because look at where this angle is. They have to share the same. They have to share the same chord. So let me just show you some. Maybe let me give you an hint. You are looking for something sharing, something going on the same year. You see this one here, from year to year. Check and see if any other angle, apart from this angle, which other angle is on the same chord from our arc segment.
So DC.
Which one? No, Sina, which one are you talking about?
DC.
DC. No, DC. DC, and it's not on the same. No, this angle is on the same. Listen here. I need the angle which is on the same chord AD. Look at it. Look for any angle which is on the same AD. BC. Guys, everybody, you can see this angle here. Everybody see this angle here? This angle and this angle, are they not on the same chord? Look at it. This angle
Yes,
here
sir.
is sharing AD, and this angle shares the same AD. Are you seeing that? Now, you just find this angle a while ago. What was the angle? What was the answer for this?
44.
What was the answer? 44. So if it's 44,
44.
here is going to also be 44. As simple as that, because they are sharing the same what? Arc segments. Everybody see what I'm talking about? So DAC. Oh, hold on. Do you know that I put the angle different DAC? And guess what I put the angle? Okay,
Sir,
never mind.
DC.
Yeah, no, it's supposed to be, go look at it. I put it different DAC. This angle I should be looking for. Everybody see that?
Come here, sir. No, man, I don't.
And you couldn't say anything? All right. So let me back up, right? We are not looking, let me see something here. Because the slightest mistake you do, it can throw you off. Okay, let me go back. Just give me a minute. I need to clean everything I did here. Okay, so no, this angle should be 44. That should be okay, right? Is it a way I can find that? No, okay, all right. Let me just see this one here. Suppose we don't know this one yet. Right. Let me just go over it one more time. Give me a minute. All right, cool. DAC is this angle here. Let's go over it one more time, right? DAC, we want to find this angle, not that one here, right? Well, I did mix up a while ago. DAC, we want to find this angle, right? All right. Any idea to find that?
Sir,
Yes.
with the
Which one?
would it be the 90? Hold on.
No, sir. It's right in front of we, right? This, you see the same thing we used to find, this angle here, similar thing to that.
So I was just saying the 90 minus the 44 would give us.
No. Okay, watch this. This angle is on this axis. It's on this. Okay, look at it. Let me just clean this part here. Let me use this color here to show you everybody. Do you realize that this one here, I need a different color. It will give me, okay. Look at this one here, right? This one coming this way, everybody see that? This angle is on that. And this angle too is on the same arc segment. You see that? This is what I'm trying to say here.
Yes, sir. So because it's on the same segment with me, that
right, it's the same,
also
right? So it's on the same segment. Right. You see what I'm saying? Look at it. This angle and the angle B and angle A, this one, they're on the same, they are sitting on the same chord.
Sir, but when did I say never wrong?
No, but you said something about 90 minus something. That's why.
But it's still the 46. You have fight against me.
No, how will I fight against you? All right. So, let me see. So this give me what? This is going to be 46 degrees, right? Everybody understand that? Who don't get that? Right. So here we have to be, okay, hold on. Somebody says something. Let me see that. Okay, Tamara, okay, good. So what should have happened, right? What should have happened, right? I just want you to observe something here. I'm just going to clean what I have. Now look at this one here, this second one here, right? Do you realize that if you draw this, right, that means saying this angle, these two angles here, they're on the circumference, right? But they are sharing the same arc segments, or in other words, they are sitting on the same chord. So this angle and this angle, they are the same, right? They say this angle and this angle, why? Because they are sleeping on the same chord, or they're on the same chord, or they're on the same arc segment. Follow? So I want to look at this one here. Look at this. This one is coming from this arc. Are you seeing that? And this angle is also coming from the same arc. They are both sitting on the same chord. So that means these two angles, they are the same. So if here is 46, if here is 46, this angle is going to be 46. I don't know if you see it. Okay, good. All right. So here now, this one is going to be 46 degrees, right? We say because angles, you are going to say angles in the same segment, are equal. Right. Angles in the same segment are equal. So we've answered 2 questions so far, right? We struggled, but we still able to answer it. Okay, so let's look at the next one now. The next one is angle BCE, right? Angle BCE. Now, anybody can help me to find angle BCE. Where will I locate angle BCE now? Angle BCE. Let's try and locate angle BCE. BCE. Where is B? B, C, E. They want to find, oh, they want to find this one, B, C. They want to find this angle. All right. Oh. How will I find angle BCE?
And I'm yelling, I can. My friends are yelling, yes, you can do it, jump, and I did.
Zena. Now, remember that we say this side is 46, right? If it's 46, 46. All right. Now, my focus here, I want to find this angle here. Right. How will I find this angle? Anybody? That's also simple. It's very straightforward. No, not really straightforward, but it can still, you can easily get it. Who want to try? What would be the angle CBCE?
This classroom, we're rock climbing every day.
Sir,
Yes. Now remember that the angle is between tangent and a chord, right? That angle is between tangent and a chord. So look at one of the theorems. One of the theorems we have on the screen who can help me to find that easy. Try and figure out which of the theorems you need to do that. Which of the theorems will allow me to find that angle?
so is it the one that says the angle between the tangent and the radius is 90 degrees?
No, you could use that one, but that is a very long process. Okay, so
The alternate segment.
you could use that one. Okay, let me see if that will make. So this is radius, right? No, let's try one which is straightforward. This angle here, and what's the relation between these two angles here? Look at it. This angle and this angle, right? This angle, this angle. Look at which theorem is talking about that.
Sir, alternate segment theorem?
They are alternate segment theorem. That's all what you need to know, right? These two here are the alternate segment theorem. Look at it. Here they see that this angle is for that side. Everybody see that, and this angle is for what? That side here, right? So the last one is actually alternate segments, right? That will be alternate segment. Oh, somebody was saying something. Okay, so that will be alternate one. This will be alternate segment theorem, all right? Alternate segment one theorem. So the alternate segment theorem would have been 20. This would be 20. 28 degrees, right? 28 degrees, right? Then we are going to use that. We say that alternate, right? Segment theorems are equal. Alternate segment. Right. So in other words, we are going to say that angle BCE, right? It will be equals to angle CAB, right? So that will have been clear. Then you get your full mark. Now, so as you realize, it's not a difficult question, but you just have to apply yourself and just look into the theorems very good before. Because the first one, when you look at the first one, right, it's angle in a semicircle. The second one, angles sit on the same chord or angles in a segment, right? And the last one is actually the alternate segment theorem. Okay, any question right there? Any question? Any question? All right, so we are keeping on. Azani, you sleeping? Azani. Azani doze off. Oh, no, let me see who is here. Mila, are you here?
Yes, sir.
Yes, sir.
Okay. Dijani here. We can hear Dijani. James, Azani, Jadine, Kesian, are you here?
Yes, sir.
Christine, Nas,
Yes, sir.
Nas here. Nas,
Yes, sir.
Nas, Shakina, Zina. Don't worry, we'll soon get the easy stuff, right? But let's deal with the difficult things first out of the way. All right. So let's go now. Any question with this one here? So basically, we've done the session B of the 2019 paper, right? We'll look at the session B, which are the most challenging questions, right? So let's go now to I don't know if you guys can see this question good. Somebody gave it to me to look at it, right? They sent it to me to look at it. I don't know if you guys can see it good. Can you see it good?
Not really.
Yes or no?
No, sir.
No, sir.
James, can you tell me which year was this so I can look for it? Okay, let me just try something. Wait. I'm going to try something. Let me just stop share. Right. Let me see if I made it in a way. Just give me a minute, guys. All right, so I'm trying to see if we can see the picture a little bit. We don't know, but I'm trying to see. All right. So I am trying to come up with something, guys. Just give me a minute.
Sir, check your chat.
Yeah, huh? All right, I'm coming. Just hold on. J G H. All right, I'm coming to. Hold on, just a minute. Okay, let's try this and see. Okay, somebody send me. Oh, May 2016. Okay, all right, cool. All right, so let me look for the question. They say it's May 2016. May 2016. All right, so we are going to look for it now. All of us is going to look for it together. Okay, let me see if you guys see this one first. Let me just show you guys first. If you see it, then later, if not, can you see it now? Can you see the question?
Yes, sir.
Anybody not seeing it? Okay, so we don't have to go and look for it. Okay, great. So let's look at this question here, right? The first question, okay, I need you to sketch it. Can you do that for me? Everybody should sketch and write the questions down. Right. This is going for 8 marks, right? 2 marks each. Can you draw, just sketch it somewhere in your book, right? And we'll look at it. Do you need a term? Do you want me to put a term beside it? Are we all right?
Put it beside it, please.
Okay. All right. Okay. So let me, I have to, before me, I can do that. I have to come out of that first. Wait. Just give me a minute, guys. I've been asked to put it beside it. Right. So I come here. Give me a minute. Copy. Paste. Oh, no, you can still see my screen. What are you seeing now?
They're in PowerPoint.
Okay. Okay, let me see something. Look at it. Okay. Okay, can you see now?
Yes, sir.
All right, cool. All right. I'm happy here. Okay. So let's see. How will I do this one? So I'll give you some time first. Think about it. So here now, from H to E, you the same thing as for E to F. Am I right? That's what he's saying. Am I right? So in other words, say this side and this side will be equal. So if this side and this side are equal, what do we call this type of triangle? EHF. What type of triangle is this?
Isosceles.
Isosceles triangle. So right. So if it's isosceles triangle, if this side is 44, right, then the first question they ask for angle EFH. EFH. They want to find this angle here. What will be this angle? Easy 2 marks. If it's isosceles triangle and this side is 44, and want to find this angle here, what will I do?
Sorry, is it is it 68?
No, this is 44 now. This side is what? 44.
So which angle are you asking for? Angle F?
Angle F, right here, this one here. So remember that if this is isosceles triangle, basically this, which two angles are equal? Because if two sides are equal, two angles will be equal. Am I right?
Yes, sir. So angle
Right, so-
F and H would be equal.
Angle F and H. So that's where we start from there, right? F and H will be equal. So I just want to start from there so everybody understand what is happening here. So in other words, we are saying that this angle here, right? And this angle here would have been the same. Right. So how do I find this angle here? Which angle F? What will I do? When you add 1, 2, 3, how many degrees you supposed to get?
Sir, 180. So sir,
180. Yes.
since
So if
we
it's
know
180.
that the thing is 180, could
Mhm.
we subtract 44 from 180?
Exactly.
We get 136.
Okay, so for the first, so in other words, for you to find it, that being 180 minus 44 divided by 2.
Yes, sir.
All right. So that's how this, right? Then 180 minus this, right? Well, remember that we minus, then we divide by 2 because it's isosceles triangle, right? What do you get? 180 minus 44, what do I get?
132.
132. So 132 divided by 2, what do I get?
68.
68 what? Degrees, right? The main thing you are going to say that triangle EFH is isosceles. Or
Wait, sir, that's wrong. It would be 180 minus 44 would be 136.
136 and divide by 2, you get what?
Then we will get the 68. The 68 is
Okay.
correct.
Okay, all right, cool. Thank you. Any question with the first one? James, are you here? Are you going to bed? James?
Yes, sir.
Okay, you see what was done a while ago?
Yes, sir.
You understand it, right?
Yes, sir.
All right, good. Now, so don't fall asleep yet until we finish this question at least, all right? Now, the next one is angle FGH, right? So let's go to FG. So now remember that we are going to put this angle here. This side is 68 degrees. Let's write it here, 68, and this also is 60 what? 68. Let's put them inside, right? To make so that everything will flow. Let me just see what I can do here. Wait, I need to clear this. So this one will be 68 degrees. This is going to be 68 degrees. All right. The next one they asked me for FGH. Where is F? Where is F? F, G, and F, G, H. F, G. They want to find this angle now. Everybody see that? Okay, so how will I find that angle? How would I find that angle? F, G, H. Anybody? Okay, somebody give me answer. I don't know if the answer. Angles in a semicircle. Nance, which angles are you referring to? Which angles in a semicircle? So if it's angles in a semicircle, nice. The only angles in a semicircle, this angle and this angle here would have been the same. This and this would have fallen the same diameter, right? So that's the only one I'm seeing, but I don't know this one, I don't know this one either. So the question is, what do I do? But it's still easy now, guys. Easy. I've just picked it up a while ago.
Sir, I'm not sure. Is this one angles the alternate segment theorem?
No. Let me see. That and that. You know, it could have worked. Yes, it could have worked. It could have worked. It is 68 degrees. Okay. Yes. All right. I think, but I'm going to, okay, so just let's try something first, right? I think it will be the alternate segment theorem. It would have worked with the alternate segment theorem because that would be angle between the tangent and chord, right? So that would be 68 degrees. I agree. But I'm going to, okay, so let's do something quick. So this will be 68 degrees because this angle here, right? This angle here and this angle here will be alternate what? Alternate segment, right? So that will be 68 degrees, right? Alternate segment theorem. Alternate, right? Segment theorem. Now, I am going to try something quickly. And so I'm going to do some calculations and realize that maybe we should get back the same thing. Now, remember that thing. Just work with me, guys. This will be 90 degrees. Everybody see that? All this angle will be 90. Agree with me? Because this is angle in a semicircle, right? Now, then, so here will be 90. Just checking something. Here is 90. This angle here, all this angle here should be 90 degrees too, because this is the radius and the tangent. So that means 90 minus, somebody should help me on, what is 90 minus 68? That will give me
22.
22. So here will be 22 degrees. Now, when you add 90 plus 22 for me, what do we get? 90 plus 22, what do we get? That's giving one word. 112.
112.
Now, minus 180. 180 minus 112 will give you 68. Yes, so that's correct. So I did it in different manner, right? Different way, but you still get the answer. So actually it is alternate segment theorem, but I was checking it from different angle. But so that is cool. So we've gone with that. What about the next one? JHE. So here would have been 68 degrees. Let me just put it inside that, right? So this one will be on 61. 68 degrees alternate segment. So let me just write angle. Let me just write that one. Angle HFE is equal to angle FGH. All right. Now the third one, what will it be? HJE. HJE. They want to find H. Where is H? H. No, sorry, it's J first. J. H E. They want to find all this angle here. You see that? Everybody see that? J H E. They want to find all this. So in other words, say we need to find only need to find this angle, right? You know this angle, then you add it to the 68, and that will give you the answer. How will I find that?
Sir, can you
Eh,
repeat, please?
No, I'm asking Ali. We want to find angle JHE, right? Let me just show you what I'm looking for. We are looking for this angle here. We are looking for this angle. Look, we are looking for this angle. You see this one here? The one, right? We want to find all this one. We want to find from JHE. We want to find all this angle here. But we know that this side is 68. For me to answer the question, I need to find this small angle. So once I know this small angle, I'm good to go. You understand what I'm saying? But it's still easy. Let me ask you guys, what is from here to your from how many degrees? From here to your, give me what?
90.
90.
90, good. So what will be this angle? Now remember that thing. If that will give me 90, right? I just want you to observe what I'm going to tell you now. Do you realize that thing? Do you guys realize that thing? OP and OH, they are radius. Everybody see that? That means that this will form what you call isosceles triangle. POH will form isosceles triangle. Follow? Meaning these two angles here will be the same. This angle and this angle will be the same. So what we are going to do, the first thing we are going to do here, right? We would have used that opportunity to say 90. So this will give me 90 degrees. All this one should give me 90 degrees, right? So I'm going to find, I'll say 90 minus 68, which give me what?
22.
22. So if here is 22 degrees, this angle is also going to be 22 degrees. So there will be 22, and this is going to also be 22. Follow what I'm saying? Right? So we are establishing that these two angles, right? There'll be 70, there'll be 22 degrees, and you're going to be 22 degrees, right? So that's what we have to do first. Then this is for this will be for angle. I want to use this angle OPH, right? OPH will give me this. We say therefore angle JHE is going to be equals to 22 degrees plus 68 degrees, right? So 28 plus 68 will give me what? We get 90, am I right? Oh, but you know that I don't have to go through that neither. You know why I have to go through that? Remember, guys, that OH is also radius, right? And this line is tangent line. This one, HE extension is also a tangent line. So all these sides also should form 90 the same way. Right, we could have done it that way too. That's also, but anyway, we work out this way, right? Okay, you can also say that OH is tangent, or perpendicular. OH is tangent line towards HE. Then we get also, that also give me what? 90 degrees, the same way. Right. So either you use this method or use that method. You get about the same answer. Okay. Somebody asked me a question. All right. What next now? J, they want to find JGH. How will I find JGH? Right. JGH. Anybody? JGH. JGH. Oh, that's easy. How do you find JGH? Who can tell me the answer quickly? Then we just move on. Angles in the same arc segment. Okay, so look at it now.
Standing on the same chord, right?
Okay, so look at the bigger picture. JGH. Look at it. J, then you got G and what? H. Everybody see that? So this angle here, they are looking for this angle. So look at it again. Look this one and look at that one. Do you pick up anything? Okay. Because we have too much this thing writing on it, maybe you can't see it. Okay, so let me just clean it and you see. Do you see now? Do you see what I'm talking about? Look at it. JG, they want to find this angle. JGH. This one is the diameter, right? This is what? Diameter, and this is the angle in a semicircle. Everybody see that?
Yes, sir.
Right, so definitely the last one, the last question is angle in a semicircle, 90 degrees, right? So the last one is going to be 90 degrees, angles in a semicircle. That should be 90 degrees. This is what 90 degrees, right? Angles in a semicircle. For this one. It requires you to know the theorems to answer the questions. All right. Okay. Any questions so far? So we are moving away from this now. Any question? Okay, let's okay, hold on. So why wouldn't you use the same arc segment are equal? Okay. No, so Tamara, the question I asked now, which segment should have been equal there? How do we get y by itself? So you have 3. We have 3. It's not even writing. What happened here now? Oops. Wait, guys, excuse me. All right, let me say something. My mouse is acting up. Just give me a minute, guys. I'll come to it. Okay, come back. So we have 3x, right? Minus 4y is equal to 5. How do I make y the subject? Talk to me. What will I do? How do I make y the subject?
So you're going to over the 3x.
You carry over the 3x, so it'll be negative 4. Negative 4y is equal to negative 3x plus 5. Now remember that they want you to write in the same manner, right? You want to write in the form of y is equal to ms plus c. Then what will I do next?
So y equal
Y equal, yes.
negative 3x
Mhm.
over 4
Over negative 4, yes.
plus 5.
Over negative 4, good. Right. So we get both of them, right? So we get 3x over negative 4, then 5 over negative 4. What will I do next? What will I do next now? Then you realize that the negative will affect everything. So your answer would have been y, right? Is equal to negative will cancel. So you get 3 over 4x. Now negative positive will also give me that, so it'll be minus 5 over 4. So this is the answer they're looking for. Okay, so somebody asking why, because this was positive 3x, you carry it over the equal sign. So when you carry it over the equal sign, it was positive, but it turns to negative. Do you see that? It was right here, positive 3x, but you carry it over, it becomes negative 3x plus 5. Then you'd have canceled the 2 negatives here. Okay, cool. Now, the next question they ask, they want to find the gradients, right? The gradient of line L. How do you find a gradient? So this same equation here, this same equation, so this is a new equation. They say this one and this one, they are the same. But they want to find out what's the gradient now. What's the gradient of our equation?
Sure, 3/4.
3/4. So the gradient should have been what? 3 over 4. Next question. The point P, right? So this I'm going to explain to you with a line. So suppose I have a line, right? I have this line here. Follow me. This is the line, right? The equation of line, yeah. And they want to, they say that there's a point P. The point P here is R and 2. And it is on the same equation of a line, which is 3x. 3x minus 4y, right? 3x minus 4y is equal to 5. And they want you to find the value of r. What do you think we will do? What do you think we'll do, guys? How do I find the value of r? Anyone? First of all, before you can answer this question, right, you have to observe that the r here is for x, and then this one is for y. So you're going to take your equation 3x, right, minus 4y is equal to 5. You substitute these values inside. Whatever you're asked to put r, so it'll be 3r minus 4 minus 4y. Your y would have been 2, so 4 times 2 is equal to 5. Now remember that the main aim is to find what is the value of what? R. So you transpose, so you get 3r minus 8 is equal to 5. So it'll be 3r is equal to 5 plus 8. So 3r is equal to 13. So r will be equal to 13 divided by 3. Right. So that will be the value of r. So let's go one more time. You take the same equation, they equal it to 5. The original equation, wherever you have x, you put r, and wherever you have y, you put 2. So you get, instead of 3s minus 4y plus 4, you take 3r minus 4 times 2, which is 8, is equal to 5. Then you move the negative 8, which is here, to over this side, you can positive 8. So get 3r plus 5 plus 8. 3r is equal to 13. Then r is equal to 13 divided by 3. All right, then we would have worked it out. What's the value of r? 4.70. Anybody can give me the answer in decimal?
Four point 333.
4.333. Okay. All right, guys, don't sleep on me, all right? Just keep me awake. We're doing good so far. So look at the next question. Find the equation of line. They say, find the equation of the straight line passing through the point C0, which is perpendicular to L. They use the word perpendicular. Now, remember, they use the word what? Perpendicular. So this is the key word here. They use the word perpendicular. When two lines are perpendicular, what happens to their gradients? When two lines are perpendicular, what happens to their gradients? Anybody remember?
So is it that you turn negative and flip?
Yeah, you turn it around and you put a negative number. You're right. So first of all, we are going to find M1. Our first gradient is actually 3 over 4. We are going to look for M2. For me to find M2, you flip it, then put 4 over 3, then put a negative number, because if they are perpendicular, M1 and M2, they are perpendicular, right? So I use if perpendicular M2, you flip it up, which of negative 4 over 3, then you put a negative number, right? So we are going to use this new gradient to find write the equation, but we are going to find C now. Find C. So we find the new gradient, which is this. So our M2 is going to be negative 4/3. Then it should pass through the point 60. This one is X, this one represents Y. And this will be the M. So you write the formula, Y is equal to MX plus C. My Y would be 0, is equal to my M, which is negative 4/3. My X would be 6 plus 0, right? Then what we do, 3 goes to 1 time, 3 goes to 2 times. So get 0 is equal to negative 8 plus C. So 0 plus 8 is equal to C. So C is equal to 8. Right. Now, when we finish now, we want to write the equation, right? So the equation, we substitute, remember that you are going to substitute M and C in the equation in what? Y is equal to MX plus C. So the answer going to be Y is equal to negative 4/3 X plus 8. This is the answer, right? So remember, guys, what we need to do here. What we need to do here is this: we find the gradient, right? We find this gradient, which is our M2, and we find a C, which is the y-intercept. We substitute those two in the equation. So finally, this is what we get as my answer. So let's go one more time. So the first thing we have to do is this: if they ask for the perpendicular gradient, would have gone, we will go and look for the original gradient, which was 3/4. The fact that they use the word perpendicular, we get the same gradient. We flip it and put a negative number. So instead of 3/4, we flip it and put negative 4/3. Then with this one, and they say you pass through 6 and 0. So I'm going to find the y-intercept, which is my C. So I have 4/3, negative 4/3, right? Then 6 and 0. I substitute this one inside the formula, work it out, find what is C. When I work out, I got negative 8. Then bring it over the second positive. So that means in my Y, that my M2, negative 4/3 plus my C, which is 8. So you always substitute the M and the C in the equation. Are we there? Any question? Any question? All right. Talk to me. What is this?
Sorry, repeat.
Look at what question is this? What type of question is this? What you see on the screen?
Simultaneous equation.
Simultaneous equation. So do that for me, everybody. You know what you do, right? Everybody know how to solve simultaneous equation now, right?
Yes.
All right, so go ahead and let's do that quickly. Right, so I'll give you some 5 minutes. Everybody should try and do something. 2 adult tickets and 3 children tickets cost $43. Statement 2, 1 adult ticket and 1 ticket for child costs $18.50, right? So they want you to, they say that let X represent adult ticket and Y represent child ticket. What will I do?
Right, 2x
Okay, so get 2X, yes,
plus 3y
yes.
equal 43,
Okay, got 43, yes. And the next one,
and x plus y equal 18.
18.5, right?
18.5.
All right. So that will give you 2 marks. Everybody see that? Easy 2 marks. Then the next part, now they say you should solve. They say solve the equation to determine the cost of an adult ticket. They want to find what is the value of adult. Adult is X, right? So how will I solve this one? They don't want the child ticket. They're only interested in the what? The adult ticket. So remember, even if you go ahead and just do the X and Y, you don't get extra marks. So your focus is to find the value of X. That is what they say. Solve the equation to determine the cost of an adult ticket. What will I do? So in other words, how do we solve this simultaneous equation? 2x plus 3y is equal to 43. Then x plus y is equal to 850. What will I do? Okay, which one should I go back? Go
Should
over.
I work with the y?
Why? Oh no, I'm responding to somebody's message they've sent me. Oh no, you mean the previous one? Okay, hold on for me. Oh, okay, all right. They say, look at it. They say, okay, fine, I got it. 2 adult tickets, right? 2 adult tickets and 3 children tickets cost $43, right? Then the statement 2, 1 adult ticket and 1 ticket for a child costs $18.50. So they say that let X represent the cost of an adult ticket and Y represent the cost of a child ticket. Write 2 equations in X and Y to represent this information. So wherever we have adult, we use X, and wherever child, we use Y. That's what they are telling us. That was we were told in the sentence, right? So look at it. Let's say let X represent adult ticket and let Y represent what? A child ticket. Write 2 equations in X and Y to represent the what? Information. So instead of two adult tickets, we say 2x. And instead of 3 children tickets, we say 3y is equal to 43. Then we say, they say that in 1 ticket, which will be 1x, which is the same x. Then 1 ticket, which is the same 1y, right, is equal to $18.50. You get that now? Okay, cool. Now, so how do I solve this equation now? How do I solve this equation? Now, I've been asked to find, somebody was saying something a while ago. Casey, were you the one?
Yes, sir.
Okay, so Casey, how will I solve? I did say I want to find the value of X. So which one will I eliminate?
Y.
Y. Okay, so how do we eliminate Y here? What will I do?
We'll multiply the top row by 1 and the bottom row
Yes.
by 3.
Then what will I do?
And then here this multiplies. It said 2 times 1 is 2, about 2x plus 3y equal 43.
Yes.
And then 3 times x is 3x plus 3 times y is 3y. And then 1850 times 3 is 55.5.
What will I do next?
And then after you do that, you would so since it have the same sign, you would make one negative.
Right. So we change one of them to negative, right? So what we are going to do is this, whether you change the top, right? So what the ideal thing is this, you can take either one of them and put negative throughout, right? So 2 minus 3, what do we get?
-1 or negative x.
Negative 1x. All right. This time they give me minus this, and this will cancel, right? So you'll be negative, negative, and negative. You see that? If you multiply here, everything will be negative. So that's what you get. Equals to. So this and this would have cancel. Then 43 minus 55, 50. What do we get?
Negative 12.5.
Negative 12.5. Right. So we want to find x now, right? So for me to find x now, they say they're only interested in x. So x is equal to negative 12.5 divided by negative 1. Cancel. So that's giving me 12.5. So it means therefore one adult ticket, right? I can say that therefore one adult ticket is equal to $12.50. Now, if in case they ask for both x and y, then I'm going to substitute. I would have substitute x equal to 12.5 in, let's say, in equation 2, right? In equation 2, right? So suppose I want to find y. Let's assume that I want to find y, right? I never wanted to do that, right? So equation 2 would have been x plus y is equal to $18.50. So if adult ticket is $12.50, 12.5 plus y is equal to $18.50. Then we want to find y. Y would have been $18.50 minus $12.50, which gives me $6. It means adult ticket is $12.50, while the child ticket is what? Child ticket is $6. Child ticket would have been $6. So I can put here, therefore, adult ticket right, is equal to $12.50, and the child ticket is equal to $6, right? We don't have to Any question? Any question?
No, sir.
No, sir. Can you scroll up to the top of the question, please?
So what we do, right? What we do here normally, we are going to the first question they asked me to find the coordinate of R. So the R obviously was 0 and 3. Then they asked me to reflect triangle PQR that a reflection of triangle PQR in a line is equal to y is equal to 1. So when it came to the y-axis and we go to 1 and we draw the line at y, we say y is equal to 1. Then we count from the R to the red line, which is the mirror line, and count the same thing going down. So 0, 1, 2, 0, 1, 2. We do the same thing for the P, 0, 1, 0, 1. Then we do the same thing for the Q, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Then after that, we're going to join them now and draw the reflection of the triangle PRQ. So this. Everybody have that?
No, sir.
Mila, what, you don't have it?
Sir, it's not me answer.
All right, so remember what you're going to do now. You count from the R to the red line and count the same thing going down. Look at the 0, 1, 2. Then you count again 0, 1, and 2. Then get R prime. Then do the P 0, 1 to the red line, 0, 1 to the prime, the image. Then you count a 0, 1, 2, 3, 4 to the red line. You count how many boxes to the red line. You count the same thing going down. 0, 1, 2, 3, and 4. When you finish, you join them and draw your triangle. That makes sense. You follow?
Yes, sir.
Now they have something here. No, they say that triangle P double prime Q is a reflection in line of that in the line X is equal to the line P prime Q prime in the line X is equal to 0. Now, do you understand that? When they say reflection of P, look at what they say, reflection of P double prime Q double prime, P double prime Q double prime R double is a reflection of a triangle PQR, P prime Q prime in the line X is equal to 0. When it says X is equal to 0, which one are they referring to? Okay, let me back up. Somebody asking, okay, somebody's asking how we got the line Y is equal to 1 before I move on. Look at the sentence here. They say triangle P prime Q prime is a reflection of triangle PQR in a line Y is equal to 1. You see it's on a line here, Y is equal to 1. So you look for 1, go to the Y axis and look for 1. This is 1, right? The missing line here is number here is 1. So you come and draw the line through the 1, and that is Y is equal to 1. All right. So it depends if they say, suppose they say X is equal to -1. I'll go to the S axis and locate -1 and draw the line through the -1. You get that? All right. Let's see now. When they say, so we are supposed to reflect this one now, right? We're supposed to reflect what we got a while ago now in the line S is equal to 0. So the question I ask you guys, what is S is equal to 0? Which reflection are they asking me to do?
So
When I
is it,
say, come again.
so is it the line in the middle of the graph, like the vertical line?
What do we call it?
So the mirror line.
So when they say y(x) is equal to 0, is referring to the, in this one is the same as for mirror line in the x-axis, in the y-axis, right? This is the same as for mirror line, right, in the y-axis. So I'll give you some few tips on this. If they say x is equal to 0, they mean mirror line in the x-axis, in the y-axis, in the y-axis, all right? And when they say y is equal to 0, they mean mirror line in the x-axis. So this is a language you have to understand. And it's very simple to interpret. If the x is 0 here, if the x is 0, right, but then that means that this, the y is the reflection line. And if the y is 0, that means the mirror, because it will pass through the y. If y is equal to 0, if it passes through the y number, right, what is it? That's what? The x-axis. You realize that? And if x is equal to 0, the number will pass through the what? The y-axis. As simple as that. Everybody see what I'm saying?
Yes, sir.
Right, so just use the language, you should be okay with that. So now we are required to reflect this in the x is equal to 0, meaning x is equal to 0, meaning the mirror line in the y-axis. Because if this is x and it's equal to 0, when I draw the line through there, that will be the y-axis actually. All right. So let's go. Did you get to write the notes I put a while ago about the x-axis and the y-axis? Everybody write this one down already?
No,
If you don't know it, please write it down, because that will help you somewhere. It will make you move faster. Okay, so we are going to try and reflect this in this one now. So I need a different color. All right, so let's go. If I'm reflecting this one here, I'm reflecting this one in the y-axis. We can't, the R will be the same R, am I right?
So
The R will not move. So there we'll get the same R1 right here. Then we look at the P. The P now, remember that we are reflecting the Y now. So we are reflecting the Y-axis. That's the main thing. We are reflecting the Y-axis. So we can't say 0, 1, 2, 0, 1, 2. So we put a P double prime. Here would have been P2, right? Then we can't say 0, 1, 2, 0, 1, and 2. There be what? Q2 double prime. Then the R. The arrow, so we are going to draw from here to here. So we are going to get something like a butterfly. Everybody see that? So you're going to get something like a butterfly. Any question?
No, sir.
Okay, and I have a question here. Sure, no problem. Okay, I need to change the color because the color a little bit wet. I over clean. Don't worry, I'm just going to do that over. Let me do this one first. All right. So this one was right here, right? 0, 1, 2, 0, 1, 2. So we right here to us. Okay, so this was like this. Right. And this one was going this way. And this one was R. All right. So what they said is they say I should draw a different reflection, right? I'm trying to draw a different reflection, but this time it's for P double prime, Q double prime, R double prime, a reflection of PQR. That means I'm using this to draw the other one, but the reflection line is S is equal to 0. Now I explain to you that if the line is S is equal to 0, that means a mirror line is in the y-axis. That explain that, right? So that means we are reflecting the same thing in this y-axis. Now, why y-axis? Because they say S is equal to 0. If S is equal to 0, when I come to the X here, I'll draw the line through the 0, and that will be the same thing as my x-axis. My y-axis would have been the same as my axis. All right. So what we are going to do, we are just going to reflect we are going to reflect it. So here now we count from the P to the mirror line, which is the Y. You count the same thing go over as I say 0, 1, 2, 0, 1, and 2. So this point here you see here, I name it P2, P double prime. Why double prime? Because you are using this one to get that one. Then the R here would have been, the R2 would have remained the same place because it's right on the what? And then y-axis, so you don't move it. Then the Q 0, 1, 2, then count again 0, 1, 2. So there would have been what? Q double prime. Are you seeing that? Then what we do next, we join them, right? We are going to what? Join them. So you join this with that. You join this one with this one here. And join this one with that one there. And join this one with this. All right. You get it now?
Yes, sir. All
right. So that's the idea, right? So the most important thing you should know when they say that reflection the S, reflection the Y, that type of thing, then if it's Y is equal to 2, depends on whatever they tell you. Right. If they say X axis, you go to the Y and draw the line through that number and just work it out. Okay, so let's go. There's another part to the story now. What do they say now? Describe fully transformation from, look at what they say now. Everybody see that? I should describe fully a transformation that maps P double prime, Q double prime onto triangle PQR. So they are saying that I need to describe, watch this one now. Follow me, everybody. They want me to describe from year to year, from this one to this. What type of translation is that? What transformation is this?
Reflection.
Hold on. This and this, what is it? From this one here, from the first one to the original, what type of reflection is that? What type of transformation?
So rotation.
No, it's not. It's not. What do you say? Rotation?
Just would it be translation then?
No, no, it couldn't be. It couldn't be. It couldn't be. It couldn't be translation. I am thinking of something. Probably that is it. Okay. Somebody mentioned something a while ago. Mention what you said again. It is not actually translation. If it's translation, if it's translation, right? It will stay the same way. The rotation will not change.
So it's rotation.
It is rotation, but how do you know that it's a rotation? No, it's not. Okay, let me just explain. It's not a reflection either, because if it's a reflection, it has to face each other, right? This and this, they are not facing each other. Everybody see that? This color here and this one here, they are not facing each other. So it's not actually this. It's not reflection and it's not translation. It's not enlargement. The only option would have been what? It would have been rotation. Everybody see that?
Yes.
So what we have here is a rotation. Now, can somebody, okay, so somebody should Google this one for me. After two reflections, what do you get? If you reflecting something after two reflections of the same, you reflect it 2 times, what was the end result? Somebody should figure out and tell me. Yes. So before I just do anything, just for the record, if you want to find triangle P to describe single transformation, triangle P double prime Q double prime R double prime onto triangle PQR, we see triangle P double prime Q double prime R double is mapped onto triangle PQR by rotation with the center 0, 1 and angle of rotation 180 degrees. All right. Then the next question, they say that the triangle PQR undergoes an enlargement of the scale factor to calculate the area of enlargement, the area of the image, right? So look at it, the area of the image, right? The area of the image is equal to, the area of the image is equal to K square times the area of the object, the area of the object. So write it down. I repeat, the area of the image is equal to K square times the area of the object. So that's how you find the area of enlargement, right? This is the same time, the area of image is the same time the area of enlargement. So we have to go and look for triangle PQR. We have to find, before we are going to do anything, we are going to find the area of PQR. Now, can somebody look at this one carefully and tell me, how will you find the area of triangle PQR here? Look at this triangle and tell me, where do you think I can find angle area of PQR? What will I do? How do you find the area of triangle PQR? You don't see it?
Sir,
Yes.
would it be half base and the height?
Right. So that means so the area here, the area of this one going to be half times the base times the height. Right. So let's go for the base. So you can do this. Everybody see that? This will be the height and that will be the base. Follow me up. So it will be half. The base will be 1, 2, 3, 3 units. The height will be 2 boxes. So this give me 3 square units. Right? 3 square units we get for the what? 3 square units we get for the area of the triangle. Are we clear? 3 square units. So now let's go back to this. So we got 3 square units for the area of the triangle. So when they say that calculate the area of the area of the image would have been the scale factor. They gave me this is the same thing as k. The scale factor is 2, so it'll be 2 square times 3 square units. Right. The area of the object, which is PQR. So this will give me 4 times 3, which give me 12 square units. Right. So my area of the triangle will give me 12 square units. Okay. I am going over it one more time, right? They said that in the triangle PQR goes on the enlargement with the scale factor to calculate the area of its image. So first of all, to calculate the area of the image is k square, which is k square times the area of the object. So the scale factor is also, that's what we call k, right? So we say k squared times the area of the object. We know that k is 2, so it's a 2 square times the area of the object. So how do we find the area of the object? We have to go back to the triangle itself, calculate the base and the height. So when you check it out, you can look at it this way. This side is the base, and this one be the height. The base have three square units, 1, 2, 3, right? So it'll be 3 boxes, right? Then the height have 2. So it's a half times 3 times 2. The 2 cancel the 2, that is 3 square units. So this is the object. So remember that this is the object, right? This is a triangle of the object. This is the object, and you want to find the image. The image is not here, right? So, but they ask you to calculate the area of the image. So we use this formula here. So that means k squared times the area of the object, which will be 4 times 3, which give me 12 square units. We follow? Any question?
No, sir.
All right. So
Sir?
yes, go ahead, Ali.
You can just re-explain it, please.
Sure. So when they ask you to calculate the area of image, right? The area of the image, or the area of enlargement, right? Normally we say the area of enlargement is equal to k squared times the area of the object, right? So what we have to do, they gave me the scale. They say the scale factor is 2. So that means there will be 2 square. So the scale factor is 2, so it will be 2 square. Follow? Times the area of the object. So we go to the object. They say the object is PQR. You see that? How do I know that? They say the triangle PQR undergoes. That means this is the original. Follow me through. So we go to the original triangle. Let's go there and see what happens. What happened here now? Give me a minute. All right. So we go here now. We want to find the area of this. So if you want to find the area of this, Alicia, you have to look at this triangle, right? But look at it from different perspective. Now this part here, this part you see here, right? This one here is going to be the base, and this will be the height. You see that? So the formula for the triangle is half times the base times the height. So my base here would have been 3 boxes, 1, 2, 3. I get a 3. Then times the height. The height is 2 boxes. Cool. So you'd have said 2. So 2 going to cancel the 2. Let you follow 3. So get 3 square units. So this the area of this PQR will be 3 square units. But if you want to find the area, the formula for area, right? If that means you have a big triangle and want to find the area of that, they are going to say that the formula is K squared times the area of the object. So what is your K? They told me the K is 2 square times the area of the object. Of course, the area of the object here would have been what? The 3, right? So you down this one give me 4 times 3, then you get what? The 12. You see what I'm talking about now?
Yes, sir.
So that's how they got, that's how we did this one here, the last one. The area of the object, the area of the image is equal to K times the area of the object, which is PQR. Then I'll work it out and get that. Right. So they are sending me another question they want me to look at. Let me see if I can find it quickly. 0. So this will give me 0. Guys, we are doing good so far, right? Right. So they'll put here 0. Right. They say on the same axis, draw on the same axis on page 16, draw the line y is equal to. So I need somebody to write these ones down for me, right? Negative. So can somebody write the table down for me? Because we are going to do on the graph paper now. We are going to the graph part, but we need to get the numbers.
Yes, sir.
You have it, Casey?
Yes.
Okay, so I guess you screenshot it. All right, so we are going to, they say in on the same axis. Page 6, where is page 16? This one, everybody see that? So on the same axis, right? Which is this. So I need you guys to try and see if you have a graph paper, sketch this one for me so that because apparently what happened, right? Apparently they were giving the coordinate geometry question first from this, right? Then after they get the coordinate geometry question, now they ask them to draw the quadratic graph on the same graph. Everyone understand what I'm saying? Okay, let's concentrate with that. Then later we can answer those questions they ask here too, all right? Okay, so what's the first one? Hold on for me. So on the same axis, what do we have? Can you please tell me the figures on that?
-2 on the x-axis.
Hold on. So X and Y, right? The first one is on negative one?
-2 and 5 in the y.
The next one,
Then
negative 1.
1, 0. Then 0 and -3. And 1 and -4. And 2 and -3. 3 and 0.
3 and 0.
And 4 and 5.
Okay, 4 and 5. Okay, so listen, they say that on the same axis, right? I'm supposed to plot on the same axis. So they'll give you this and you're supposed to plot this on the same axis. Remember that you're supposed to draw the line AB2, right? So we start plotting the points here. I'm using this because I need to make it officially. So I need a different color. Okay, good. So the first one is -2 and +5 will be right here. Follow everybody. Right. -2, +5, then 0 and what? 0, -1. Wow. All right. No. -1 and what? A bit wrong for this. Okay, so they have -1 and 0. -1 and 0 will be right here. 0, -3 right here. All right. What else now? Which one I'm supposed to plot now? Which one I'm supposed to plot?
The one at -4.
1 and -4. 1, -4, yes. After that now, which one?
The 2 and -3.
2 and -3, yes. Then which one now?
3 and 0.
3 and 0, yes. Which one now?
4 and 5.
4 and what? 5. All right. So we are going to what? Draw the curve now. So we are supposed to draw a smooth curve, right? So that'll start from here. Then go through that. Then go through this. Then we go through that. All right, so then you are going to write here the equation, right? Which is what was the equation again? Anybody remember?
For the function, sir,
Yeah, for the function, yeah.
y equal x squared minus 2x minus 3.
Right, so you are written in this way. Follow? So then we are going to see if you can answer the questions now. Everybody have the graph them? So what do you say now? What was the next part of the question? They say, use the information and the state the minimum value of y is equal to where x is equal to. Right, the minimum value of fx occurs at x is equal to what? So let's go back to the graph. What? Okay, let me ask the question. What are they asking right here? What are they asking right? You know, who can tell me what are they asking for? When they say the no, you know the minimum value. Look at it again. Read it again and you see. Look at what they say. The minimum value y is equal to x minus 2 occurs at occurs when x is equal to what? So when they say x is equal to, what are they looking for? At the minimum value, you want to find the value of x. What are they looking for? So look at it. This is the minimum value, right? This is the minimum value. Everybody see that? This part here will give me the minimum point. At this minimum point, what's the value of x?
1.
1, right? So that means the question they ask is the same thing as asking for axis of symmetry, right? So this one here, when you draw this one coming this way, this one is what we call the axis of what? Axis of symmetry. All right. So let's go back to the question. They are asking for the same thing, asking for what? Axis of symmetry. So remember that this question is also referring to axis of symmetry, which would have been the same thing as x is equal to 1. So let's look at this one here. The values of x, the values for x for which x squared minus 2x minus 3 is equal to negative x minus 3, x plus 3, x is equal to that and that. What are they asking? Look at it. They write the what? The function, and they write the data of the straight line. So if you're thinking of what they are talking about here, they say the equation, the function equals to the what? The straight line, the curve and the straight line, x and x. What are they asking for? Look and tell me, what are they asking for here? What are they asking for? When you write one equation with other one like that, what are they referring? And they put the equal sign between them. What are they asking for? Anybody want to try? Casey, what do you say? Mila, what do you say? Jordan, what do you say?
So repeat the question.
When they say the values of x for which this equation is equal to that, and they say you find x equals to that, x equals to what are they looking for? Like you say this question, what actually are they asking for?
So I'm gonna ask for x.
They're asking for x. Now, when you look on this graph here, look at the graph. Let's go back to this. So this is the straight line. They say the curve is equal to the line, and you should find the values of x. What are they asking me to look for? It starts with a letter R or S. When the curve and the line meet at a point, right? What normally do you look for? Look at this. This function, this equation is equal to, they say, okay, let's assume that I give you this equation and this equation. I say you should work it out. What are you going to look for? Normally, what will you do?
Find x.
You find x, meaning you find the solution, right? You have been asked to find a solution. But how do you find a solution here? You are finding what you call the roots. You find what you call the roots, right? So that's why I said that either solution or what? Roots. I give you the clue S or R. So how do you find the solution for between the curve and the line? And pay attention to this, because this is something you can easily get in the exams, because they are combining straight line graphs with curves now. So where do you get a solution between the curve and the line? You come here, right? Everybody, you come to this side and you go down and read the value of x. So let me use different color. You look for the intersection where the curve and the line meets. I repeat, you go to the intersection where the curve and the line meets, right? So you go to the intersection where the curve and the line meets, then you go and find the value of x. Then the other one, you would have been right here. So the two solutions, this would be x1 and this would be x2. Everybody understand? Yeah, we can't go anywhere because guess what? It's right on the x-axis. Where the curve and the line meets, that is the roots. So we are talking about, this is the roots, right? The roots, or the what's called the solution. What number is this? What number is this? -2. And what number is this? And what number is this?
3.
3. So we go back to that question. We go back to that question. And we are going to put here x is equal to -2 and what? 3. And you get your 2 marks. But they expect you to know that it's just like we are solving. So this is similar to when they give you, like, you should solve a quadratic equation and not this one. So this is x squared minus 2x minus 3. And they gave you, this is y. And it's another one, y is equal to -x plus 3. And they ask you to solve this equation. Now remember that you could solve this one by graphical method, and you can also use it by what? Simultaneous equation using method of substitution, right? So the graphical method is what we've seen at the front here. This is one here, is the graphical method actually. We have the curve and we have the line. So where the curve and the line meets, right, you go to the x-axis and read the value, and that will give you the what? The solution or the roots of that particular question. Are we clear? But I'm a little bit curious before they ask them before, because we never do that, right? Look at what they say. Determine the equation of the line parallel to, they use the word what? Parallel to the line x plus y is equal to 3 and passes through the origin for 2 marks. Anybody can tell me what needs to be done here? So one quick question. When 2 lines are parallel, what happens to their gradient? When 2 lines are parallel, what happens to their gradient? Nobody? When 2 lines are parallel, what happens to their gradients? Parallel lines have the same gradient, right? Parallel lines have the same, M1 is equal to M2. So for you to work out this, all what you have to do here, you are going to rewrite this in the form of y is equal to ms plus c. So you are going to say x plus y is equal to 3. So y is equal to -x plus 3. So what is going to be is that the gradient will be equal to -1. If gradient is -1, you are going to find c. For you to find c, they say you pass through the origin. The origin would have been 0, 0. If it's parallel, they have the same gradient. So the gradient M2 also going to be -1. Then you want to find c, y is equal to mx plus c. You substitute the values 0, -1, 0 plus c. So this gives me 0 is equal to 0 plus c. So c is equal to 0. So all to do, you're going to write the equation now. Y is equal to mx plus c. So your y, the m will be -1x plus 0. That will be the answer for the first one, right? They say parallel. We did the perpendicular line with the other question, so I'm not going to that. All right, so any question here? Any question?
No, sir.
All right. If you're not asleep, give me a wave.
Can I write it down?
Okay. If you're not asleep, give me raise up your hand. Let me see. Yes, Jordan. Who else? Who is not asleep? Wow, me have 5 people not asleep. Christian gone to bed. Mercy. Okay, all right, cool. Don't worry, guys. It will pay off, yeah. When you pass, some people will be jealous. You tell them that when you are the class from whatever time to whatever, where were they? Let me look. Okay, so we are going to look for one last question, right? So if you are giving AO plus OB, right? AO plus what? OB, what we are going to do here, you move from A to O, then O to B. The vector that we are giving here was O to A, and we want to find the inverse of that, reverse of that. So because it's reverse, we put a negative of the same thing, 2 negative 2 plus OB. OB going the same direction, right? So when you work it out, this will give me negative 2 positive 2, right? Plus 6 and 1. So this will give me 4 and 3 as my answer. Everybody see that? Now, who can tell me how will I write AC? How will I write the vector AC?
Then would it be AO plus OC?
Right, it will be AO. Yes, you're right. AO plus what? OC, right? So this will give me AO is the same thing, should be negative bracket 2 negative 2 plus OC, which is 10, 10 and 4. So this give me 2 negative 2 plus 10, 4. Right, so this give me 12, 12 and 2. Mm-hmm. Easy 3 marks, right? Easy 3 marks for those 2 here. They say, hence determine whether A, B, C are collinear. Give reasons to answer. So when you mean collinear, collinear means what? Straight what? Straight line. So this is how I'm going to demonstrate it for you guys, right? I'm going to draw one straight line like that. Let's say I have this, right? And I am going to divide it into 3. So I start from A. I say this is A, right? This side is B. Let's say this side is C. Now, this is the vector from A to B, and this is the vector from B to C. Then we have all that now, right? So for me to prove that is collinear, there are three points in collinear, 3 main things you need to know about collinearity. First, they have to have a common point, right? So when you look at here, the common point here, so rule number 1, common point is B. So it passed the first one. Common point is B. Right, the common point is B. You have to get a common point. The next thing is the same. It has to have a multiple of one another. right? So we are going to compare AC. Look at it. AC from A to C is 12 and 2, right? And let's look at AB. AB is 4 and 3. Now, what can you tell me about these two here? Look at the two vectors. AC is 12 and 2, AB is 4 and 3. What can you tell me about them? Look at the figures. I want you to look at the figures. What can you say? Four, 3, 12, 2. What do you observe? Nobody? Jaden, you not sleep yet?
Yes, sir.
Talk to me. AC is 12 and 2 and AB is 4 and 3, right? What do you observe in those two vectors?
It's 2, 2, and 4, and 3.
What you did to AB to get AC?
Yeah, add the vectors from before.
Okay. What do you do to 4 and 3 to get 12 and this or oh no, this is what do I have here? Me have something missing. 12 and 2.
Yeah.
And this is what?
You put 4 and 3.
4 and 3. Hold on. Let me just revise something. Something missing. We can't pick up something missing here. So AO. Okay, AO is what? AO is 2, right? So negative, and this is that. That will give me negative 4 and 3. Now, OC, this will negative 2, 2, negative 2, yes, plus 1. 10 and 4. Oh, I pick up where I mess up. That's fine. Nobody saw what I did wrong at the last one. Nobody saw what I did wrong at the last one. What I did wrong.
Yes. It is supposed to make the 2 negative.
Exactly. Exactly. So I have to go back and change that. Let me see. Okay, it's part of the whole thing because I was checking I figured it out a while ago that this one here wrong, right? So that gave me the wrong answer for what I wanted to do. Okay, it's okay. So this should give me what? This should give me negative 2. Negative 2 and what? 2. Right. So that means the answer here should change, right?
Yes, sir.
The answer should be what?
Yes.
This answer should be.
It's 6.
That should be what? 6.
Yes.
No, 8 and what?
6.
8 and 6. Yeah, 8 and 6 now. So we have to change this one. So we are going to compare it one more time. Let's go. Why this one not clean up? Is it? All right. So I think I have to use. Give me a minute, guys. We get through. We're almost there. Okay. So what happened is this, right? We see that AB, the vector AB is 4 and 3. And the vector AC is what? 8 and what? 6. Now, so one of the things for you to prove that thing, one of the things you have to prove that thing, they actually collinear. First of all, collinear also means straight line. Is that okay? Collinear also means straight line. So before you can prove that, first of all, you have to have a common point. Common point, right? Common point here. Our common point would have been B. Everybody follow that? That is the first thing we have to establish. Then apart from that, after we find a common point now, we're supposed to also attest that, look at AB and AC. What do you observe? Look at the figures. What you did to AB to get AC?
You times it by 2.
We times it by 2. So we can say that AC is equal to 2 times of what? AB. Everybody understand that? The vector AC is equal to what? 2 times of AB. So we can say that therefore they are parallel, right? They are parallel. They are parallel, and they have the same gradient. They have the same what? Same gradient. Now, so once they have these conditions, yeah, that means they are collinear. We say therefore A, B, C, right, are what? Collinear. Now, so remember that the first thing you have to prove that they have a common point. How do I know that? When I draw A to B, then what? A to B, then B to C, then everything is on a straight line. So the B here, this is the common point, right? Common point. Common point. After I get my common point now, I have to compare from A to the C first. I find the vector AC, which was 8 and 6. Then I find the shortest one, which is from A to B, then compare. See what is common among them, right? So when I check it out, what is common, I realize that the common factor is 4 and 3, meaning you multiply AB by 2 to get what is AC. Right, so I say AC is equal to 2 times of this. Once I can establish that they are multiple of one another, we say they are parallel and they have the same gradient. Therefore, ABC are collinear. Any question? Any question?
No, sir.
All right, so I think, guys, I did try my best, right? And you guys also try your best. I hope that